fossil evidence, and I'm very pleased to be here today talking about the fossil record of one of my favorite groups of birds, and I suspect for most of you here some of your favorites as well, the nightjars. Before we jump into the fossils, let's put nightjars in the context of their family tree, that is, what other birds are they most closely related to. Recent anatomical and especially genetic studies, including work done by myself and my colleagues, have provided strong evidence that nightjars are members of a group of birds called Strysaures, making them close relatives not only to several other groups of nocturnal birds, such as the oilbird, potoos, frogmouths, and owlet nightjars, but also to the diurnal swifts, tree swifts, and hummingbirds. Members of Strysaures tend to have small and delicate skeletons, which is not a great combination for fossilization, because this means that their skeletons are easily destroyed before they get the chance to be buried and form fossils. However, we actually have a surprisingly good early fossil record for many groups of Strysaures. There are several fossil sites, especially from the western United States and Germany, that have produced large numbers of well-preserved fossils, bird fossils, from the Eocene epoch, about 50 million years ago. This is partly because some of those fossil sites formed on the bottoms of calm, low-oxygen lakes, which had little to disturb the bodies of animals that sunk into their depths. Members of Strysaures were clearly very diverse at these localities during the Eocene. For example, from western North America, we have this fossil of a stem oilbird. That is to say, it doesn't have all the traits that would classify it as a modern oilbird, but it's more closely related to oilbirds than to any other modern group. We also have stem potoos, and you can see that in some of these fossils here. There are even feathers preserved. There are stem frogmouths, stem apodiforms, that is, early members of a lineage uniting both swifts and hummingbirds, stem swifts, and even stem hummingbirds. So, what about nightjars? Well, up until recently, I would have had to tell you, not much. None of the fossils from these excellent lake sites had been identified as stem nightjars. There were a few scrappy fossils, like these partial wing bones and a partial foot from eastern North America, and some partial shoulder bones from France that have been considered possible stem nightjars, but they are so incomplete that whether they even have anything to do with nightjars is quite questionable. So, yeah, maybe. Here's a diagram showing the major groups of Strysaures again, and how they're related to each other. This is scaled against time, with present day on the top, and going further back in time towards the bottom. The thick solid lines indicate the extent to which we have confidently identified fossils for each of these groups, and as you can see, many of these groups have fossil records extending to about 50 million years ago, but with nightjars, there's this conspicuous gap. To be fair, they're not exactly alone. We don't yet have a good early fossil record of the owlet nightjars either, and we don't have any known fossils for the tree swift lineage at all. But it's still pretty weird, isn't it? Nightjars are very diverse today with over 90 living species, and they're found on every continent except for Antarctica in modern times. So where are all the stem nightjar fossils? Well, as it turns out, we might have had them all along. So there's this group of fossil birds called the Archaeotrogonidae, which were described in scientific literature during the late 19th century, so we've known about them for a long time. So far, they have been found in Europe, specifically England, France, and Germany, in rocks dating to the Eocene to Oligocene epochs, about 55 to 24 million years ago. At some of the fossil sites in France, they are actually some of the most abundant bird fossils. Even though their remains are so abundant, however, most Archaeotrogonids are known from isolated limb bones, so for a long time there was a lot of confusion about what type of bird they were. They were originally thought to be closely related to trogons, which are a group of tropical birds that aren't closely related to nightjars at all. That's why they're called Archaeotrogonids, meaning ancient trogons. This was based on the fact that some of their wing and shoulder bones bear a superficial resemblance to those of modern trogons. Eventually, however, the discovery of Archaeotrogonid skull material from Germany and England showed that they had broad, short beaks similar to those of nightjars and swifts, and strongly suggested that they were members of Strysaures instead. More recently, just last year in fact, this species of Archaeotrogonid pictured on the slide was described from England. Its bones are very well preserved in 3 dimensions, and based on the details of the bumps and pits for muscle attachment on some of these bones, it was proposed that Archaeotrogonids might have been most closely related to nightjars among Strysaures. If that turns out to be correct, that would make Archaeotrogonids stem nightjars. At this point, we even have nearly complete skeletons of some Archaeotrogonids from German lake deposits preserved with feathers, which gives us some insight into how these possible stem nightjars might have lived. In general, their wing and tail feathering resembles that of true nightjars, and along with the swift-like head, this suggests that Archaeotrogonids might have fed quite similarly to modern nightjars by catching insects while flying through the air. Several specimens have even been found with this barred pattern on the tail feathers. In living members of Strysaures, this is a color pattern seen in nocturnal species and probably functions in camouflage, so maybe Archaeotrogonids were nocturnal too. Some Archaeotrogonids had a very unusual feature, and that is these bony spikes protruding from the wing bones. There are no living species of Strysaures that have similar structures. But there are some other birds, like certain plovers and waterfowl, that do. Those birds use their wing spurs, as they're called, to fight each other and defend their young from predators, so it's interesting to think that some stem nightjars might have done the same. Another notable difference between Archaeotrogonids and modern nightjars is in their hind limb anatomy. Archaeotrogonids had a much wider ankle joint than modern nightjars, and unlike modern nightjars, they hadn't lost one of the bones in their outermost toe. It's difficult to say what these differences mean from a functional perspective, but it has been suggested that the distinctive foot anatomy of modern nightjars is an adaptation for roosting and nesting on the ground, in which case this may indicate that Archaeotrogonids were a more tree-dwelling group. So those are some highlights from the early fossil record of nightjars and their close extinct relatives, but how about their more recent fossil record? Here's another chart scaled to geologic time, showing the time ranges of some possible fossil nightjar discoveries, and don't worry if you can't read the names clearly. So far, the youngest known Archaeotrogonid fossils are about 24 million years old, and here we hit another gap. No fossils of nightjars or stem nightjars from the entire Miocene epoch, from about 23 to 5 million years ago, have been described in the scientific literature. Although this is a bit frustrating to those of us interested in the bird fossil record, it is not that surprising. There isn't much in the way of fossils for other members of Strysaures from this time interval either. It may be that we haven't found many good Miocene fossil sites that are good at preserving their remains. So the next time we pick up nightjar fossils again, geologically speaking, we're about 5 million years ago in the early Pliocene. Here nightjars are represented by the shoulder bone from South Africa, and we think that this bone belongs to a modern type nightjar. That's not to say it was a living nightjar species, it almost certainly wasn't. However, it would have been a member of the modern nightjar group, and we would expect it to have had all the features that modern nightjars today share. We find more modern type nightjar fossils at even more recent fossil sites. Here's another shoulder bone and a wing bone of one that was discovered in some tar pits in Peru. It's about 15,000 years old, which counts as very recent by geologic standards. It would have been alive during the last glacial period, or what we commonly think of as the so-called last ice age, although technically from a scientific perspective we are actually still in an ice age right now. This extinct nightjar was given the name Caprimulgus pierensis, but I've put the name Caprimulgus in quotes here. At the time it was named, many of the nightjar species that live in South America today were classified in the genus Caprimulgus, and these fossils were thought to be similar to some of those living species. However, if you're a hardcore nightjar fan, you probably know that the genus Caprimulgus is now only used for a group of Afro-Eurasian nightjars, and the American ones have all been reassigned to different genera. So it may be that this extinct species should really be in the genus Hydropsilus or some other American nightjar genus, but someone needs to do a detailed restudy of these specimens to really figure that out. And these nightjar fossils may not be the most spectacular specimens. I might add, isolated, incomplete bones like these are much more typical of what we find when we discover bird fossils than the stunning lake-preserved Eocene fossils I showed earlier, but these still contain some valuable information. For example, that modern-type nightjars existed in Africa by 5 million years ago, and that there used to be a nightjar species in Peru only a few thousand years ago that is no longer alive today. But wait, there's more. The fossil record can also tell us about extinctions that happened in historical times. At least 2 nightjar species are thought to have gone extinct in recent centuries, the Cuban porwheel of Cuba and the closely related Jamaican porwheel of, well, Jamaica. Of these, the Cuban porwheel is only known from fossil remains. Here's a partial foot. The Jamaican porwheel, on the other hand, has been found both as fossil remains and recorded alive, but there have been no confirmed observations of a living one since the mid-19th century. It is quite likely that it died out due to the introduction of invasive predators as well as habitat loss. But hold on. As you probably know if you've done field work with nightjars, nightjars can be pretty hard to find. They're mostly active at night, and they're very well camouflaged when they're resting during the day. Considering how cryptic they are, some researchers have considered it plausible that the Cuban porwheel and the Jamaican porwheel may still be alive in remote parts of islands that they live on, at least in very small numbers. Personally, I'm not enough of a field biologist to judge how likely that might be. However, such a thing is not unheard of in the field of nightjar research. The Puerto Rican nightjar was originally named in 1919, based on a museum skin and some fossils, before living specimens were reported in 1962. So maybe, just maybe, in these cases, the fossil record is not only a cautionary tale of the biodiversity that we've lost, but also of the biodiversity we could hope to find and conserve if we act quickly enough. Alright, last slide. Why do we study the fossil record? Well, it is the only direct evidence of the appearance and diversity of life forms that have gone extinct, including those that gave rise to everything alive on Earth today. We probably couldn't have predicted that nightjars used to have relatives that hit each other with spiked wings and lived in trees without fossils of archaeotrogonids, for example. Fossils also provide us with data points for when specific organisms originated and where they lived across deep time. These are things that we can try to estimate by studying living species, but fossils give us the hard evidence needed to put credible numbers and likelihoods on our results. The majority of recent analyses that try to estimate when different lineages of modern birds diverge from each other make use of ages provided by the fossil record. Indeed, the modern world only provides a snapshot or series of snapshots of what ecosystems are like right now. Conservation efforts often aim to restore species or ecosystems to their quote-unquote natural state, but what does that mean? If we base our impressions only on historical records, we might be misled into thinking that the way things are now is the way they have always been. To use a nightjar example, the least horrible of Hispaniola is a relatively uncommon species and found in lowland environments today. However, the fossil record shows that about 1,000 years ago, it was actually very abundant in highland environments. We don't know exactly what happened to cause this change, but it is something we need to keep in mind when trying to determine what is normal for this species. So as you can probably see, although the nightjar fossil record is quite sparse, even by bird standards, it has shed light on every one of these aspects of nightjar evolution, and I can't wait to see what else we might discover in the future. I would like to thank the conference organizers for this opportunity, my supervisor Daniel Field for letting me know about this opportunity, and all of you for listening. Thank you very much, and I'm happy to take any questions.
Hi everyone, my name is JT Larkin. I'm a graduate student at the university.
Sorry about that. All right, so Albert is present and here for questions.
Hello.
Thank you for that presentation, Albert. That was super interesting. It's a part of nightjar research that I don't get to look at very closely very often, and it's fascinating.
I'm glad to hear it.
All right.
So
One question here. Are there any efforts to study ancient DNA?
Yes. So, hi, Noor. It's great to meet you virtually. Yes, ancient DNA. So far, that has not really been done for recent nightjar fossils, especially, I suspect, because it's harder to preserve ancient DNA in tropical environments, which is where a lot of the recently extinct nightjars are from. But there have been successes with some other tropical birds, recently extinct ones. So I think perhaps it's only a matter of time before somebody tries. Yeah.
Fantastic. And another question. We have time for one more question here. Are there any history of African nightjar species? Is there any African nightjar species?
Yep, African nightjars, not a whole lot, but as I mentioned in the talk, the oldest known fossil that's been described in the scientific literature of a modern type nightjar comes from South Africa, and it's about 5 million years old. That's a pretty significant find in that respect. But yes, in terms of individual African nightjar species that are around today, I don't think much has been found of them in the fossil record as of yet. The African fossil record of birds is very understudied, so I'm sure there are lots of great discoveries to be made there.
Absolutely. Great. Well, thank you very much, Albert. We're going to move on to our next presentation here. Thank you for the questions, everyone. All right, so our next presentation in the natural history session is titled Go Big or Go Home, the use of ARUs to evaluate whippoorwill response to forest management across large spatial extents. This is presented by JT Larkin. JT is a graduate student at the University of Massachusetts Amherst, where his thesis research is focused on eastern whippoorwill response to forest management.
Hi, everyone. My name is JT Larkin. I'm a graduate student at the University of Massachusetts Amherst. This is my second year in the program here at UMass, and I'm planning on finishing up my thesis this coming up January, which is focused on eastern whippoorwill response to forest management, and is also the focus of this talk here today. But before I start talking about my research, I want to get into the importance of monitoring. So every year, professionals from around the world put a lot of time and effort into monitoring various wildlife species, and this could be for a variety of reasons, which may include evaluating a species' response to management, estimating population sizes to inform bag limits, and assessing population trends, such as what we see at the Breeding Bird Survey. However, monitoring has several challenges associated with it. It's time intensive, it's often constrained to specific time and date windows, it's expensive, it's dependent upon optimal weather conditions, and it's oftentimes hard to find qualified individuals to conduct the monitoring. So all of these challenges combined make the spatial extent at which we conduct our research much smaller than we'd ideally hope for. Now, there is technology that helps facilitate larger scale monitoring efforts, such as camera traps, radio telemetry, and more recently, autonomous recording units. And these units are used to monitor species via auditory cues. And they're really growing in popularity as the technology itself, its analysis, and the cost of these units is becoming more user-friendly. So now I'm going to start getting into my research on the eastern whippoorwill. The eastern whippoorwill is a nocturnal aerial insectivore that's been experiencing significant population declines over the past half century, and these have been primarily attributed to habitat loss and degradation. As you can see here with the range map on the right, eastern whippoorwill inhabit the forests of the eastern half of North America and are really associated with a diverse set of forest conditions. And monitoring for eastern whippoorwill is very logistically difficult. The surveys need to be conducted at night. There's a very limited survey window, so there's two-week windows annually that are centered around lunar cycle. And sometimes surveys take place in dense young forest patches. Additionally, surveys typically follow a protocol similar to that of the Nightjar Survey Network. And one of the issues with this protocol is that they have road-based surveys, which often does not monitor management footprints very well, as management typically occurs farther away from navigable roads. However, this is where ARUs come in and can really help facilitate whippoorwill monitoring efforts, as these units can be placed out during the day and left at a site for weeks on end to record. My research had two main objectives. First was to assess whippoorwill occurrence across a gradient of forest management intensity, and second was to identify site and landscape level characteristics that influence whippoorwill occurrence. So across the eastern US, there's several state and federal agencies that are putting forth a lot of time and effort in creating habitat for threatened and declining species, such as the golden winged warbler, the New England cottontail, and the cerulean warbler on private lands. Additionally, these same agencies are putting forth a lot of effort on their own public lands to create habitat for these same species. Now, the monitoring of these focal species response to those management efforts typically occurs. However, monitoring for species such as whippoorwill usually does not. So this really set up a unique opportunity for us to answer some important questions about whippoorwill use of these sites. So in 2020 and 2021, we deployed 1,827 autonomous recording units ranging from Western North Carolina to Southern Maine. 579 of these units were deployed on private lands, 1,248 were deployed on public land. And these units were really placed across a variety of management practices, which ranged from mature unmanaged, such as what you see in the upper left-hand corner, to shelter woods, overstory removals, and clear cuts. So moving into our recording unit methodology, again, whippoorwill surveys are constrained to specific date windows. So there's two-week survey windows annually. So we programmed our units to record for 3 hours a day, from 3:30 to 3:45 a.m. and 9 to 11 p.m., which are periods when whippoorwill are noted to be active, and 6:30 to 7:15 to capture associated songbird species. And we deployed our units to capture at least one of the 2 survey windows. So after we had left our units out at a site to record, we returned in late June and early July to collect the units and conduct a quick vegetation survey. We wanted to quantify microhabitat variables such as basal area, stem density, ground cover, etc. Once we had collected all of our units and conducted all the vegetation surveys, I returned back to the lab to start quantifying landscape level variables. So data sets such as the NLCD or U.S. Forest Service's forest type data set at several spatial extents around each survey location. So once I had my landscape and microhabitat data, I was ready to start processing our recordings. So over the course of the 2 years, we collected over 60 terabytes worth of data, or 140,000 hours. And this is equivalent to about 16 years of straight listening. So since it's not feasible for a human to sit there and listen through 16 years worth of recordings, we had to develop a machine learned classifier. And to briefly go over what this is essentially when we train the computer to identify the image of a whippoorwill song. So to build a classifier, we had to find clips that had whippoorwill singing in them, such as what we see on the right-hand side here. Now, once we identified the clip as having whippoorwill singing, we went into a program called Raven Pro and physically drew a box around the whippoorwill song. And we did this for hundreds of clips until we were happy with our classifier's performance. So then once the classifier was developed, we ran it on our own real data set from 2020 and 2021, and it chunks all of our recordings into 5-second clips and generates a score for each of those 5-second clips. And after listening to several thousands of those clips, we were able to identify a threshold at which there was no more false positives. So a score of 4.3 or higher was always a whippoorwill. So using that threshold score, we were able to generate a detection history for each site using the top clip from each day. So not all of our units successfully collected data. Some of them failed due to water damage, others due to bear. And additionally, some of our units were deployed for other species. So we had some songbird species where the units were placed closer together. So after spacing all of our units 500 meters, which was our requirement for my research, we had 1,265 units or survey locations. To give you an idea of what these survey locations look like, on the X, this is a simple bar plot here. On the X-axis is basal area, and on the Y-axis is the number of sites. So as you move from left to right, you go from an image that's in the upper left corner there on the left-hand side of the bar plot. So over here, looks more like this image. And as you move right, you have sites that start to look like this lower image over here. 562 of our sites had whippoorwill present, so we had a naive occupancy of 44%. And the analysis that we chose to use on my data set was a logistic regression. But before we ran our logistic regression, I had to run univariate models to identify the most significant spatial extent for each landscape level variable. Once we identified those spatial extents, we tested for a correlation among all of our variables that were going to be carried into our logistic regression analysis. So my logistic regression had 4 model sets: a regional model set, a microhabitat model set, a landscape model set, and a combined model set. So the combined model set contained the variables from the previous 3's top models. Additionally, we had to account for the variation in the amount of recording from each unit, because not all recording units stayed out in the field the same amount of time. So to do this, we weighted our models with the number of survey days. And then finally, only variables in the top model that did not have confidence intervals overlapping 0 were considered significant in our analysis. So I'm going to start moving into results, and all of my plots have the same format today. I'm going to go in a little bit of detail on this plot here. So on the x-axis, we have our explanatory variable. So in this case, basal area, and on the y-axis, we have our response variable, which is our probability of occurrence. These ticks along the x-axis here is called a rug. So this is the spread of our data. And then additionally, we have this red dotted line, which is the mean probability of occurrence. And then finally, we have our trend line with 95% confidence interval. So as you can see here in this plot, as basal area increases, so the probability of a whippoorwill occurrence decreases. Moving into some ground covers. So as the amount of bare ground and rock ground cover at a site increased, so did the probability of whippoorwill occurrence. And the same pattern held true for woody ground cover. So as the amount of woody ground cover increased, so did the probability of whippoorwill occurrence. And woody ground cover is any woody stem that is less than ½ a meter in height. We had 3 landscape level variables that were significant. First was the amount of herbaceous cover within 1,750 meters of the point. So as herbaceous cover increased, so did the probability of whippoorwill occurrence. Next was the proportion of oak forest within 250 meters. So as the amount of oak forest within 250 meters increased, so did the probability of whippoorwill occurrence. And then finally, we had the proportion of scrub cover within 1,750 meters of the point. So as the amount of scrub cover increased, so did the probability of whippoorwill occurrence. So these are just some preliminary results, but there are some conclusions that we can draw from these results. And first is that forest management that targets other species, such as the golden wing, cerulean warbler, and the New England cottontail, is in fact benefiting eastern whippoorwill. And the degree of these benefits appear to be influenced by both within stand and landscape level factors that I just discussed in my results. Now moving forward, some of our next steps are exploring how changing the definition of occurrence to a more conservative criteria influences our results, and additionally adding LiDAR variable for our Pennsylvania only data set. I'd like to thank my technicians, committee members, my many collaborators, as well as my funder, the NRCS Conservation Effects Assessment Project. And I'm happy to take any questions now, or you can always send me an email.
Great. Thank you for that presentation, JT. So if there are any questions, we do have some time for those. So you can put those in the chat. Okay, you've got one right off the bat, JT. Did most or many or few detectors actually pick up birds?
In terms of whippoorwill, we had, I would say, a lot of our detectors picked up any songbird. So these units aren't specific for whippoorwill. They can capture any species ranging from mammals to birds to insects that capture that make a noise. But for the whippoorwill specifically, we had 44%, so 500 of our sites had whippoorwill.
Great. The next question here. Were you able to distinguish individuals on your recordings?
No, that is something that is kind of difficult with using ARUs right now, is trying to pick up individuals and get abundance estimates, but I know that is currently a work in progress at a few universities right now. So, but we did not look at that, no. And I see that there's a question about what what ARU
Yes.
we used. That the brand specifically is Open Acoustics Audio Mods.
Great, and I think we have time for at least one more question here. Let's see. The chat is jumping around in here. Okay, we've got a question here from Becky. Any thoughts on the presence of oak?
Yeah, so one of the things that I think could be leading to why we see I guess a relationship with oak forest is the fact that these sites are drier, and this is a ground nesting species, and there is some literature out there that talks about the species use of these drier sites for laying their eggs, where they just lay the egg right on top of the leaf litter. So having those drier sites is important.
Great. Thank you very much, JT. If you continue to have questions, you can use the chat, or JT shared his email as well. So definitely keep the discussions going. We'll move on to our next presentation here. So our next presentation is presented by Juan Carlos Fernandez Ordonez. Juan Carlos is a biologist with the Venezuelan bird banding program and the South American and Caribbean coordinator for the Institute for Bird Populations MOSI program. This just a heads up, this presentation does not include audio, but there are captions within the slides to follow along. And Juan Carlos is doing some field work in Cuba and is unable to join us today for questions, but we are grateful to him for sending this presentation along. So we'll begin that shortly. Yeah, that was really, really excellent. So fascinating to see what camera traps can pick up for nightjars, given how how seldom I get to see the subjects that I'm personally studying. So yes, so Juan Carlos is not here to answer questions. I will say, if you do have questions, you are welcome to put those in the chat. Questions or comments you can put in the chat, and we will forward those to him and make sure that he receives those. But yeah, many thanks to him for sending that along. That was excellent. All right, and we will go into our final presentation of the natural history section. Our final presentation is titled, "What Do We Know from 200 Years of Nightjar Records in Southern Brazil? A Comparison Between Literature and Citizen Science." This presentation was put together by Brazilian biologist and ornithologist Wagner Carvirzi, and Wagner is unable to join us today, unfortunately. However, they did send their email along, and we'll add that to the chat, and you can direct any questions about the presentation to that address. So yes, we'll get that started for you, and then we'll have a small break period, but I'll be ready momentarily.
A informação sobre a distribuição espacial e temporal das espécies é muito importante, porém pouco conhecido para as espécies de bacurau, inclusive no Paraná, onde o histórico ornitológico se iniciou em 1820. O objetivo foi realizar o levantamento bibliográfico de tudo publicado até 2021 no estado do Paraná, sul do Brasil, e fazer uma comparação com a plataforma eBird. Especificamente, em quantos estudos são mencionadas as espécies de bacurau, quantas são as espécies, qual o total de esforço amostral, em quantas localidades, como as espécies estão distribuídas no tempo e como essas respostas são obtidas a partir da ciência cidadã. No total foram registradas 14 espécies de bacuraus, em mais de 4.000 horas de esforço amostral, em 631 localidades, e como no mapa é possível ver, algumas localidades visitadas preternamente não possuem registros mais atuais. Na literatura, foram encontrados 47 artigos e ou capítulos de livros, que mencionam 13 espécies, com uma média de 4 espécies mencionadas por estudo. Foram registradas uma espécie endêmica da Mata Atlântica e 3 espécies ameaçadas de extinção no estado do Paraná. Os registros iniciaram em 1820 e foram feitos em 195 localidades e pouco mais de 2.600 horas. O eBird traz o registro de 9 espécies, sendo em média 2 espécies por lista, não sendo registrada a espécie endêmica de Mata Atlântica e uma das 2 espécies ameaçadas. O eBird também tem o registro de uma espécie não detectada pelos estudos, mas os registros se iniciaram em 1995, foram feitos em 436 localidades e em pouco mais de 1.400 horas. Com relação à distribuição espacial, o eBird contribui significativamente para o conhecimento da distribuição, porém, muitas áreas permanecem sem qualquer tipo de informação. E com relação à distribuição temporal, na literatura está concentrada a partir dos últimos 40 anos, a partir da década de 80, e o eBird começou em 1995. E com relação ao número de registros, o eBird teve um pico ao redor de 2018, porém, mais da metade desses registros foi feito em 2020, quando a pandemia de coronavírus se iniciou. Então, o eBird contribui com 3 vezes mais o número de registros de espécies de bacurau em menos da metade do esforço amostral, só que a maior parte desses registros foi feito nos últimos 4 anos. As espécies de bacurau estão distribuídas espacialmente e temporalmente de forma enviesada no estado, e as espécies recentemente sem registro podem demonstrar ou a sua raridade no estado, ou então a ausência de visita a localidades mais específicas.
All right, excellent. So as I mentioned, Wagner is not here to respond to questions, but we will put their email in the chat. So you're perfectly welcome to reach out there. Okay, and with that, that concludes the natural history session, and we will have a break for just under 10 minutes or so. We'll resume at 12:05 UTC and move on to our next session. You're welcome to continue to have discussions in the chat and continue discussing the presentations there. So thank you very much. Okay, so we will resume our meeting here and move into our next session. Just a quick extra thanks to our presenters in our natural history session. Very grateful for their participation. That was excellent. All right, so now we're going to transition over to our Nightjar Stories session, session 2. And we will begin with our first presentation is Nightjar, Artistic Inspiration, Bringing Materials to Life. And this is presented by Mark Gibbs. Mark is an award-winning independent professional visual artist in the United Kingdom, whose body of work heavily features nightjars. So we will get that started for you in just a moment.
Hello everybody, my name is Mark Gibbs and I'm an artist based in the north of England. It's wonderful to be part of this conference. I'm absolutely delighted to have the opportunity to share my creativity with you. So my job is to bring inanimate materials to life. And I often use recycled materials. I make sculptures, like the one you can see on the right, and I see art as a type of alchemy. I also make drawings and paintings, and I'm going to show you a selection. I've got 10 slides, so I'm going to show you a selection. It's the camouflage of nightjars that got me into them. I just find images like this so amazing, that a bird can evolve such a effective camouflage pattern. And it sort of throws down the gauntlet to me. Can I replicate that either using recycled materials or paint, colored pencils, things like that? Really throws down the gauntlet. Great challenge. And I know many of you, there'll be many experts on watching this conference will have seen many images like this. I'm still amazed by them. So we can play a little bit of a spot the bird competition. I'll give you a few more seconds. And there it is. So here's one of my sculptures. It's based on the European nightjar, and it's the first one I made. So nightjar have a very dark sort of reputation in folklore, something I'm interested in. So a lot of my work deals with quite dark themes. I'm not positioning it as wildlife art. Yes, it is about something in nature, but I'm positioning my work within contemporary art so that it raises questions about contemporary society and contemporary themes. And to do that, I sort of embed messages within the work. So this bird uses newspaper, and I've made extensive use of newspaper with all my nightjars. And of course, the newspaper contains stories, contains meaning. So paper is a great material to use to make feathers from. A lot of my work is about metaphor, and the use of materials is some sort of metaphor. So for a metaphor, something's got to be really similar enough to work, but also different enough to work. Otherwise, it's not a metaphor. So, like feathers, paper is light. It can build up in layers. You can fold it. You can serrate the edges and barb the edges, and you can color it, or you can have printed information on. And my work often has all the combination of all of these things. So nightjar, they have a dark position in folklore, often seen as liminal beings flitting from this world and the next, and harbingers of doom, really, guardians of lost souls. It's interesting, nightjars, they need to have better PR, really, than owls. Owls, everybody likes an owl in folklore. So nightjars are quite a dark folklore. Going with that theme, this bird uses newspaper columns and uses obituary columns from local newspapers. Some of my work is mounted, some of the birds are mounted on ceramic vessels, and again, play on the word nightjar. What would a nightjar look like? Could you fit night in a jar? Moving on to a drawing. In my drawings and paintings, sometimes I take a realistic bird, again based on the European nightjar, and place them on a ground, but it's not natural ground, or at least most of it isn't. It's a camouflage pattern, a military camouflage pattern. So as soon as you use the word camouflage, I start thinking about, yes, natural camouflage, but also military camouflage. And it's very interesting, reading the literature search, militaries around the world are investigating well camouflaged creatures to find out why they can be so effective. And I see a lot of my work as a sort of hybrid, a sort of nature technology hybrid. And as such, it points to perhaps a dystopian future. So there are some dark themes in my work, but I hope you'll see we'll move from dark to light. So this camouflage pattern is a contemporary one called Cryptek, which was inspired by the hexagonal shadows cast by camouflage netting. And I think it does make a very striking image. Returning to my sculpture, this bird is called New Wars, Old News, and makes extensive use of newspaper. There's also a digital urban camouflage pattern, a pixelated one put in as well. So I always have a rule that my birds must look realistic, but the plumage contains this extra layer of meaning. If we zoom in, perhaps you'll get to see some of the snippets of text and some of the sort of pixelated camouflage pattern based on the European nightjar. I'm very interested in systems of power and obsolete power. And this bird, again based on European nightjar, is made from 1960s and 70s African banknotes. It's referencing liberation struggles. European nightjar migrate in the UK summer, Africa to the UK, and that word migrant is a very politically loaded one, and that isn't lost on me. This bird is based on a pennant-winged nightjar. These African species, the male, has grow in the breeding season an amazingly elongated tail, so wing feather, and If you look closely at mine, it terminates in a MiG fighter jet. Also, if you look closely, the plumage has Soviet stars, red ones, or white stars of the United States, sort of embedded into the plumage. The piece is called Cold War Envy, thinking about the superpower influence on African politics. This piece and many of the other sculptures shown in the presentation were part of an exhibition at the Reged Gallery called Matisse and Contemporary Paper Artists. I was really proud to be part of it this summer. I was one of the contemporary paper artists. So you can see that, yes, my work is about nightjar, it is about nature, but it also, I'm using them as a vehicle to tell other stories as well. Some of them are quite dark, but I do see them as messengers of hope. And in particular, I do see all my work overall as a prayer for peace, for world peace. And I think this is particularly true of this bird, which is based on an Egyptian nightjar, where I've used the Arabic word salam, meaning peace, and I've incorporated that into, repeated it into the plumage. So it's been a wonderful opportunity to share my work with you. Thank you so much. I think this conference is wonderful, and thinking about peace, the fact that a bird, our interest in a bird, a group of birds, can connect people from across the world from different continents. What a wonderful opportunity for international friendship. I have my social media tags on there that you can see, and I'd be happy to answer any questions you might have. So thank you very much for listening. I'm just going to click on the screen to stop the recording.
Thank you very much for that presentation, Mark. That was really, really excellent. And I'm totally blown away by your abilities to create nightjars from those materials. They are very striking and really, really beautifully done.
Well, thank you very much, Logan. It's lovely to have this opportunity to show my work to an expert audience.
Absolutely. So we do have a few moments here. If anyone has any questions for Mark, you're welcome to put them in the chat. So Maria has a question for you right off the bat here. What reactions have you had from the public?
Well, I think people are amazed that they're not taxidermy. They are actually made from paper. But this is a very unusual opportunity for me because a lot of people don't recognize the nightjar. In the wider public, they don't really know what they look like, so that sometimes foxes them a bit. But I think on the whole, people do get the sort of message of peace and the sort of world friendship idea. I think they do. I have had some good reactions in that respect. Absolutely.
Yeah, and I can tell you as someone who looks at nightjars often, and you can see from all the encouragement you're getting in the chat, the folks that study nightjars are definitely seeing nightjars in your work. It's incredible, truly, how you've been able to capture them. You do have another question here. All right. Are people familiar with the folklore and the stories around nightjars when seeing your work?
Well, I think some people are, but in the majority, I would say that nightjars perhaps need to increase their PR because they're quite a connoisseur sort of bird. So people might know about, like doves. Doves have a big folklore, and sort of everybody knows a dove is a image of peace, as a sort of metaphor for peace. But some of the folklore about nightjar is, I think, not so well known.
Yes, yeah, I think you're right. Well, it's great that you're out there elevating them and connecting them to these themes. So I just followed you on Instagram, and you're welcome to add those links to the chat if you'd like, Mark. Definitely will be following along with your work. All right. So thanks again, and we will be moving to our next presentation. So there is a slight change in the agenda. So Mishak Pierre is not able to join us today, unfortunately. And so thankfully, Jared Del Rosso was willing to advance his presentation forward. So we won't be taking a break, but this next presentation is called The Lonesome Whippoorwill, Trends in Popular Music. And as I said, this is presented by Jared Del Rosso. Jared is an associate professor in the Department of Sociology and Criminology at the University of Denver, a trip leader with the Denver field ornithologists, and an avid bird watcher with a particular interest in common nighthawk and common poorwill. So welcome, Jared. We'll get your presentation up in just a moment.
Hi there, my name is Jared Del Rosso. I'm an associate professor of sociology at the University of Denver. The title of my talk today is The Lonesome Whippoorwill, Trends in Popular Music. This talk comes from a broader study of the cultural meanings associated with Eastern whippoorwills, including the meanings we attach to them, particularly in the US, in naming practices, folklore, literature and poetry, popular music, and really anywhere else in which meaning is assigned to this bird or conjured from this species of bird. I'm at the very beginning of this study, but I'm excited to present it to a community of scientists and enthusiasts for nightjars and whippoorwills and nighthawks and all kinds of other nightjars, so that I can begin to get feedback and hear from some of you on some of your favorite references or some of those obscure references you might know to whippoorwills or nightjars more generally. So I want to just briefly go over some of the objectives of this work, which is again at its very earliest of stages. I'm hoping to document and interpret trends and meanings associated with whippoorwills, relate those trends and findings to broader theories within the sociological study of animals and society, to reflect on the enduring meaningfulness of whippoorwills in the context of species decline and human alienation from non-human animals. So those are the three things I'm hoping to accomplish with this work. Before I talk about popular music, I do want to kind of detour through naming practices because I find this a particularly rich area of meaning making around whippoorwills and nightjars more generally. The bird seems to have a name that is simply a description of its song. Indeed, Birds of the World, the excellent resource, makes this point, claiming few North American species say their name as clearly as the Eastern whippoorwill. But of course, as with anything involving human language, the story is a bit more complex. I've seen the bird song translated as whip poor wheel, whip purr will, purr rather than poor, or a four-syllable song, whip-po-wo-will, whip purr it will, all kinds of almost unpronounceable things for me, things other than this phrase whippoorwill. This fact was acknowledged fairly early when the Finnish naturalist Peter Kalm wrote in his book Travels into North America, which was published around 1750. The English changed the call of this bird into whip poor will, that it may have some kind of signification. And Kalm indeed thought the bird said whippoorwill, whippoorwill. So the question becomes, what is this kind of signification that Kalm is alluding to here? And the answer has to take us through English disciplinary practices of the 16, 17, and 1800s. Whipping as a form of disciplinary practices was fairly common in England and the UK. They brought those practices to their colonies, and of course, the US being one of those colonial legacies, also adapted whipping. So in his book, Crime and Punishment in American History, The historian Lawrence Friedman describes whipping as an extremely common punishment throughout the colonies, especially for servants and slaves. Friedman documents that whipping was used for crimes that by modern standards were not crimes at all. Idle walking on holy days, running away from home, for instance. These were offenses to the moral life of a community or to their social order. This association, this use of a disciplinary practice in the whippoorwill's name allowed 18th, 19th, and 20th century writers and educators a sort of opportunity to tell their own moral stories through the bird. And so in educational materials, we often see this phrase, why whip poor Will, used to teach students to read. In another case, I've seen this used in an introductory kind of text to learning music. But here what you have is an excerpt of a book called the See and Say series from 1914. It's kind of like a spelling and reading book for children. The page with words beginning with W-H-I includes whip, includes whippoorwill. It was not unusual to teach children bird names and bird names like whippoorwill at the time. And it closes with this verse, poor Will, whip poor Will, why do you wish to whip poor Will? Earlier than this, in the first half of the 1800s, the poet George P. Morris wrote a poem called The Whippoorwill. It's more or less a moral story asking essentially the question, who deserves punishment? And the answer Morris comes to is basically all of us, but it includes these rather dramatic etchings. The top left etching of a whippoorwill standing like a person dressed in a long cloak under a full moon is associated with or illustrates the first verse of the poem, which reads, still whippoorwill, art thou a sprite from unknown regions sent to wander in the gloom of night and ask for punishment. And Morris basically uses this verse to then tell a story about punishment, largely in early 1800s New England and in post-colonial US. I tell you this story because it's unusual today, I think, to think of that name for the bird as a 3-word command to whip some unfortunate person named Will. And so I'm thinking about why this association and what are the consequences of this association. I will also say that my early research, my previous research focused on the politics and culture surrounding violence and torture. So this kind of a set of associations is really interesting, important, and meaningful to me. But to bring us to popular music, because this today is where we're likely to encounter the whippoorwill and cultural meanings with whippoorwills. There are 2 dominant themes that I'm seeing in my early analysis of songs referencing this bird, lonesomeness and nostalgia. I think the first is fairly well known. The second I hadn't yet encountered till I started looking at some of these songs. I'll say again, I'm in my early analysis of them. There's no database listing songs referencing whippoorwills, so I'm putting together essentially my own. If you know of a song, particularly an obscure one that you think I'm liable to miss, please do drop me an email. But to unpack each of these 2 themes for a little while here with you. This theme of lonesomeness is an old one. It predates the American standards of the early 1900s, but I'm starting with one of those standards, Birth of the Blues, which is basically a fairly famous song covered by Frank Sinatra and other influential singers of the first part of the 1900s, which tells essentially an origin story about blues as a genre of music. And part of that origin story contains a reference to the whippoorwill. From a whippoorwill high on a hill, they took a new note, pushed it through a horn till it was born into a blue note. So the whippoorwill, essentially, the story goes, was there at the very beginning of human sadness and our expression of it through blues music. An influential song, but certainly the most iconic expression of the lonely whippoorwill comes from the country singer Hank Williams in his song, I'm So Lonesome I Could Cry. The very first lines of that song, Williams sings, hear that lonesome whippoorwill, he sounds too blue to fly. This song has been frequently covered and performed by other artists. It has been alluded to, referenced in other country and folk songs, trying to conjure Williams and the whippoorwill and the meanings attached to them. So much so that we might say the image is now somewhat cliche. And in 2012, the country rock band Dr. Dog made this point essentially in their song Lonesome, when they sing, I had my fill of the whippoorwill. When he broke into song, I shot him. Leave me alone. So the idea here being a rejection of this bird as kind of our fellow traveler in lonesomeness, in part because of the clichéness of the image. Another dominant theme, again, which I wasn't expecting to find, is nostalgia. It kind of surprised me to find this, but nostalgia, meaning that the bird itself is conjuring ways of living our life, places in which we live our life, which we have lost in the 20th and 21st centuries in the US. So we're talking here about the lost worlds of rural life, country life, prairie life, Western life. Despite the bird's association with the East, we see it in the country Western songs of the early 1900s. Here you have a song associating it with all kinds of images of Western life on the plains and prairies, Java, tin cans, coyotes, and in this case, the whippoorwill. Nostalgia lasts until today. In the early 2000s, we had several songs, I'll show you one, come out from country music performers who associate whippoorwill with this, again, this kind of small town country life. So here, Daryl Worley has the whippoorwill calling him back home, back to where he belongs. And he contrasts that with the big city nights and lights that feel like a prison to his soul. It's not just country singers who build these associations. The American Bird Conservancy has posted a video of the whippoorwill singing its song over and over and over again. And the top comments to that post all have something to do with the fact that people once found this song common, growing up a simpler time in a country life, but then moving to suburbs or cities and losing their connection with the bird itself. So I'm especially interested in this question of what the bird as a nostalgic symbol represents. I'm interested in this question of what it means to live in a world where we rarely encounter the whippoorwill's song. I grew up in upstate New York and yet had never heard the bird, and yet we still encounter it in our cultural artifacts, particularly in our music. So this is one question that's animating this research. I want to reiterate in closing that, again, I'm at the very early stages of this, so I would love to hear your own favorite nightjar and especially whippoorwill references. You can email me. The email is jareddelrosso@du.edu. If you want to learn more about some of these artifacts and some of the other things I'm thinking about in relation to the whippoorwill, you can look at my blog, lonesomewhippoorwill.com. And again, thank you for your time this morning. I really appreciate it.
Thank you very much for that fascinating presentation, Jared. As someone who's very interested in the folklore and cultural traditions of whippoorwill, it's a topic that's very near to me. So I'll definitely have a few songs and poems to share with you. All right. So Jared is here and available for some questions. And I think, let's see. Yeah, we don't have it's not a question in the chat, but we've got a comment here. So while I was working at Ding Darling National Wildlife Refuge in Florida and mentioned I was going to work with whippoorwills next, so many of the older tourists all said they missed the song of the whippoorwill.
Yeah, thank you, Logan. Thank you, Ash, for that comment. I think that's really just a fascinating aspect of the bird and a fascinating aspect of our relationship with whippoorwills, nightjars more generally. I grew up in New York State in the northeastern part of the U.S., and I had really no connection or relationship to nightjars until I became a birder in 2012 after leaving the Northeast. So there's, I think, something generational to this experience of maybe having encountered them in our youth. Or not, as in my case, and some of that experience of nostalgia.
Absolutely. So Maria has a question for you here. So let's see, some in the bird world are working to rename bird names. Have you run into this for the whippoorwill in your research?
I haven't yet, but I haven't looked into it. I think what's interesting about the whippoorwill for me is I think my sense is, and just from talking with birders and the way that the bird's name is used in songs, is we kind of forget that the bird's name is actually a sentence. And it just sounds like a name now. It sounds like a 3-syllable but 1 unit kind of name. That history of connecting it to violence is really kind of fascinating and maybe not surprising, but a little curious and perplexing to me.
Yeah, it is fascinating. So Kate had a comment here. People in Montana also talk about missing the calls of the nighthawk in the summer as a indicator of the species decline. And then you did have a question as well. Have you heard any stories or folklore from Native Americans?
Yeah, thank you both for those comments and questions. Around here in Colorado, people also talk about missing the calls of the nighthawk. And I only moved to Denver in 2012, so I don't have that kind of history here. But when I talk to birders who've been here for a longer time, they all kind of know I'm obsessed with nighthawks in suburban settings around here, and they talk to me about how it used to be a regular kind of experience, both during migration and maybe during breeding season. To Chris's question, that's something that's going to be part of my research. I haven't gotten there yet, in part because in looking at some of the early European writing about the bird, there are a lot of stories shared about folklore and beliefs of both Native Americans and early English colonizers of the continent. And it's really hard to distinguish what is true in those accounts and what is kind of hearsay and rumor and conjecture. So that's something I'm going to kind of work out, hopefully, through the research.
Of course. Yeah, great. Okay, well, thanks again, Jared.
Thank you all.
All right, so that concludes our Nightjar Stories session. Thanks very much to Mark and Jared both for their presentations. Both were fascinating and grateful to them both. We're now going to transition over into a break period, but also a breakout session period. And so this will be an opportunity for us to network a bit. I'm going to have our my fellow steering committee member, Maria, introduce these and talk about the format of the breakout sessions for a little bit. So I hope you'll stick around and participate in the session. Should be very interesting.
Okay, thanks, Logan. Hi, everyone. We're so excited to have you all with us over these next few days. We are excited to offer breakout rooms for folks to come together and discuss common topics. Breakout rooms will last for about 30 minutes each day. The session topics may span multiple days, so we can have in-depth conversations and also to allow folks to switch to different topics. If a topic you are interested in is not listed, please let me know. You can email me. Sorry, my full email did not pop up there. You can email me and let me know if there's another topic you're interested in, or you can pop it in the chat here. We'll be monitoring that as well. In order to have breakout rooms run smoothly and so that we can share information back out to all participants, we would love if we had one facilitator and one note taker in the breakout rooms. By the end of the meeting, I'd love for each note taker to email me their notes with the session name, the topic that is, and the day, so that we can share it back out to all participants. Because the meeting runs at different times each day and we're not sure who will be available, we think it's best for each breakout room to arrange and assign who the facilitator and note taker are for each day. So that should maybe be the first thing after people introduce themselves. So please introduce yourself briefly to the group, and then sort of somebody please nominate yourself or someone else to be the facilitator and the note taker. If it's appropriate, we would love for some sort of common questions be considered across breakout rooms. But if it's not relevant, just let us know what topics you addressed, maybe some common themes throughout your time together. So if appropriate, what are some conservation priorities for nightjars related to this topic? What are actions or next steps related to this topic that you can share back out, that you all discuss and then can share back out with everyone? We've set up breakout rooms so that you can jump into whichever one interests you. Today we have breakout rooms for culture in nightjars, another one for migration, for breeding, another room for behavior or response to artificial light. We have one for methods. We have a student meetup, so if students want to get together and chat and network. And then we also have another room for networking for folks to just meet one another. If a room doesn't have many participants, just jump into another one. We'll leave them open in case people want to move around. But again, we'll revisit these themes the next couple days. And if anybody wants any changes, just let us know. We are completely flexible and happy to make changes. If you have questions, I'll hang back here to answer any questions, but I'm going to open all rooms now for folks. And we encourage you to turn your cameras on when you're in breakouts, if that's possible, so you can also, so you can connect to each other. All right, thank you, everyone.
Okay, so the breakout rooms have wrapped up. Thank you very much, Maria, for organizing those. I hope everyone enjoyed. We're going to get back to our presentations here and start on session 3. So session 3 is on habitat use and conservation. And we're going to start with our first presentation in this session, Chuck Will's widow use of private working forest in East Central Mississippi. And this will be presented by Rebecca Bracken. Rebecca is a PhD candidate at Mississippi State University, where her research focuses on exploring the effects of active forest management on avian communities across the lifetime of a pine stand. She works with both breeding and overwintering communities, and also works with species of conservation concern. So we'll get that presentation started for you.
Hi everyone, my name is Rebecca Bracken. I'm wrapping up my PhD at Mississippi State University, and today I'll be talking about one portion of my dissertation, the use of a private working forest by Chuck Will's widow in East Central Mississippi. We often think about forest management practices in the southeastern U.S. aiming to increase early successional conditions for breeding birds by attempting to mimic natural disturbances. But these practices are thought to also benefit aerial insectivores such as the Chuck Will's widow, an at-risk species I am researching as part of my dissertation. Chuck Will's widow are an understudied species that are found breeding throughout the southeastern U.S. But little is known about their life history, including survival rates, population densities, physical aspects of locations used for nesting and foraging, and how they use and are affected by land use patterns. One of the main reasons for this lies in the difficulty of studying this species. Chuck Will's widow are night foragers and are difficult to capture for markery site studies. Like most nightjar species, Chuck Will's widow are a species of concern and are thought to be in deep decline. As you can see in the figure on the bottom right, Chuck Will's widow have experienced an estimated cumulative decline of over 60% since 1970, based on long-term standardized surveys conducted across the United States. But a lack of data has made it difficult to know how many landscape changes have affected the Chuck Will's widow. As such, no significant conservation action plan has been developed for this species. It has been speculated that open, early successional conditions provide the appropriate breeding and foraging habitat for the species. Much of the habitat suspected to be available for Check-Will's widow in the southeast is on privately owned forest lands. Forests often managed in a dynamic or rotational schedule that could affect the long-term use by Check-Will's widow and other nightjar species. According to previous studies, both eastern whippoorwill, a similar species found in lower densities in our area, and Check-Will's widow appear to require forested habitats for nesting, but are often documented foraging in open areas. Because of this, these species may be sensitive to variation in forest structure, as well as the configuration of forest patches. Breeding habitat selection may depend on proximity of older forest patches to open patches. At the start of my project, there were no known studies investigating how Check-Will's widow use working forest systems in the southeastern U.S. Keeping all of this in mind, we had two main objectives for our study. First, to evaluate landscape metrics, including amount and age of forest cover on local abundance. And second, to estimate breeding bird density within our study system. Our study site for this project was in Mississippi, specifically in Kemper County, outside of a small town called Scuba. The area is a pine forest owned and managed by a Weyerhaeuser company, consisting predominantly of managed loblolly pine in various stages of succession. We completed road-based surveys during the breeding season, specifically May and June. Points were placed 750 meters apart along drivable roads. We started our surveys half an hour after sunset, and each survey lasted 20 minutes. During the survey period, we recorded distance and direction to each detected individual, as well as night conditions such as lunar phase, wind, temperature, and cloud cover. These night conditions are important because previous research has highlighted that nightjars vocalize more during full moons and clear conditions. For the analysis, I took my survey data and determined the location of each detected individual using the survey point location and the distance and direction values. I completed proximity analyses and determined the characteristics of each occupied stand. We had hoped to be able to model occupancy across the survey area, but every point was occupied, so I used end mixture models to determine how the surrounding landscape characteristics affected abundance instead. Before running any landscape models, I had to combine the forest stand information with the survey data. In ArcGIS, I took the survey points and created buffers of 3 different distances, 375 meters, 750 meters, and 1,125 meters around each point. Because we don't know average breeding territory size for Check-Will's widow, these distances represent circles with unique land cover data to each point, land cover data at the distance between points, which also is the average territory size for eastern whippoorwill in some systems, and then 1.5 times the average territory size of the whippoorwill. Then I combined the buffered areas with the Weyerhaeuser provided stand shapefile and determined the amount of area of each stand within the buffers. Then I determined the percent contribution by each stand in the buffer, calculated by grouping stands into 6 age categories from 0 to 30 years of age. I also determined the amount of forest edge within each buffer. Finally, I combined this information with the formatted survey data. Over 2 seasons, we were able to complete surveys at 49 points and had 295 detections. As you can see in this image, each survey point marked in pink had at least one Check-Will's widow detection, with each detection marked in blue. When we plot out the detections and determine the stand characteristics of where each detection was, we can see that stand age appears to be important to Check-Will's widow within this managed landscape. Individuals were most commonly found in stands 15 to 19 years of age, which fits within one of our assumptions, that Check-Will's widow might show an affinity for mid-age thin stands, possibly as nesting areas. Average age of pine stands with individuals detected was 17.31 years. Looking at where these individuals were within the landscape really highlighted their association with forest stands of a particular age. We suspected that individuals would be found in mid-rotation stands, those around 15 to 20 years of age, but in stands near open patches. Proximity analysis indicated that birds were very likely to be near mid-rotation stands, but there was a lot of variation in distance to nearest open stand. For my model results, I found that increasing amounts of pine 16 to 20 years post-planting had a negative influence on abundance, while pine 1 to 5 years post-planting had a positive effect. Both edge length and area had a negative influence on abundance. Neither lunar illumination or cloud cover had a significant effect on detection. The figure on the left shows how percent of pine 16 to 20 years of age had a negative correlation to Checkwell's widow abundance. The figure on the right shows the amount of pine 1 to 5 years post-planting, which had a positive influence on abundance of Checkwell's widow across the landscape. There's a pretty wide confidence interval for both of these, but given model fit and the p-value, these characteristics were significant. Using distance-based models, we were able to estimate male abundance at 1 male per 5.95 hectares in 2020 and 1 male per 8.47 hectares in 2021. Compared to prior studies, these estimates are generally in the middle. One study from Oklahoma produced estimates of 1 male per 4.5 to 13 hectares. Checkwell's widow abundance in some areas is likely conditioned on availability of certain stand characteristics. Checkwell's widow are frequently found in multiple forest stand ages, indicating that they are possibly using stands for different reasons. There clearly exists some sort of trade-off, with pine grassland conditions having a positive effect on abundance and increasing amounts of mid-rotation stands having a negative effect. My assumption is that with increasing amounts of mid-rotation forest, the amount of open conditions decrease, and the further away an open stand used for foraging might be. My density estimates align with prior research in other systems, with local densities likely influenced by stand and landscape management decisions. This research brings attention to an understudied species. In recent years, there has been a shift towards studying nightjars as a group, but much of the focus in the eastern U.S. has been on common nighthawk and eastern whippoorwill. I was able to show that this species is likely to be susceptible to changing forest conditions, but further study in other areas is needed. As an example, other nightjars respond positively to forest edge, but only when food supply in the edges is high. It's important to recognize that because managed systems like the one I work in contain a variety of forest and open conditions in close proximity, there is an opportunity to support this species here as the surrounding environment changes. More study is also needed to investigate how movement varies within the forested landscape and how management affects recruitment. We also don't know much about their diet in managed landscapes, and across the range we know very little about their specific nesting and foraging site selections. Unfortunately, even with the severe declines we've seen across most nightjar species, we still don't have information about Checkwell's widow reproductive success and survivorship. With that, I'd like to thank everyone involved in this project, especially my amazing field technicians, Tabitha, Anna, Connor, and Dan. Thanks to Weyerhaeuser Company and the National Council for Air and Stream Improvement for funding my research. Please feel free to email me if you have any questions. Thanks for watching.
Excellent. Thank you very much, Rebecca. So we have a few minutes here for questions. If anyone has any questions following that presentation, please put them in the chat and we will read them. Right. I have one for you, Rebecca. Did you pick up any other nightjar species during your efforts?
Yes, of course we did. We had common nighthawk and eastern whippoorwill, though in pretty low densities compared to the Checkwell's widow. But I can say based on our surveys, they are probably all using completely different forest stand types within that larger landscape. So I'd love to look at it further, but detections were so low, it made it really difficult.
Excellent, thanks. So yeah, you had a question here. What was your most surprising or unexpected result? This question comes from Rebecca.
Yeah, that's a really good question. I think initially we were surprised by the number of Check-Will's widow that we had. We were working a lot with Weyerhaeuser. Again, it was on their land, and we would give them our numbers, and they were like, "Oh no, you can't have that many birds," and we were very positive that we did. So that was really surprising to begin with. And then as far as the results, I was really surprised by some of the edge analysis. I know there was that paper, was it out of Illinois recently with eastern whippoorwills about edge being or having a positive effect on whippoorwills, but only when the insect population is high. And our insect population seems to be very, very high. Based on, again, just kind of anecdotal evidence. And so I'd be interested to follow that a little bit further and see what exactly is going on there.
Great, yeah. So you had there's a comment here from, I just lost it. Hold on. From Kazuhiro. So thank you for your interesting and useful research for the conservation of this nightjar species. I agree that forest reactivity is very important to nightjars. Absolutely. All right, and one final question here. Would favoring woodland edges be too influenced by moth/insect species for favoring edges?
Oh, certainly it could be. And I think that's where there's still a lot of unknowns with Check-Will's widow, like some of the other nightjars. You know, we have some base information about what their common prey types are, but not within this landscape. And so I think, again, that leaves the opportunity to look at it further and see what are insect populations like within the landscape, both on the edges and within the interior. And see where that's influencing, because they are certainly coming out to the edges and they love flying down those little side logging roads when they're foraging. So there has to be something going on, but we're just not sure what it is.
Excellent. Yeah, there's many areas to explore. We always find in this research.
Yes.
So thank you very much, Rebecca. We're going to move to our next presentation. All right, our next presentation in this session is titled Effects of Climate and Forest Management on the Distribution of the Gray Nightjar, a 9-year survey in Japan. And this is presented by Kazuhiro Kawamura. Kazuhiro is a Japanese researcher at the Forestry and Forest Products Research Institute. They started their research career exploring the large-scale distribution of the gray nightjar and its drivers in northern Japan. And Kazuhiro has continued to survey the distribution of the species for nearly a decade. So we will get that presentation started for you.
Hello everyone, my name is Kazuhiro Kawamura, a Japanese researcher. Thank you for giving me this great opportunity. This is a picture of the focal species, the gray nightjar, written by me. Have you ever heard the territorial call of the gray nightjar? This is the call. Their calls were once a typical sound of night in Japan, but not now, unfortunately. Let's move on to the presentation. The gray nightjar is the only nightjar species distributes in Japan. Here is a map of East Asia showing the distribution of the gray nightjar. Red indicates the breeding range, blue indicates the wintering range, and purple indicates the year-round range. In this map, southern Japan was categorized as an year-round range, but we believe that this species is a long-distance migrant across Japan and distributes only in the breeding or migrating seasons. The breeding range of the gray nightjar in Japan contracted by 57% between 1978 and 22. Recently, the range may have increased, but what is the cause of population fluctuations of this species? This species nests in open lands near forests, including harvested areas and young plantations less than 10 years old. This photo is an example of the breeding environment, a young conifer plantation. All of you are nightjar enthusiasts, so you can find a nestling in this photo. He or she is here. Nightjars have usually 2 nestlings, but there was only 1 nestling in this nest. The great nightjar prefers such open habitats created by disturbances, called as R-successional habitats. The population declines in Japan may be caused by decreasing R-successional habitats, like decreasing grasslands and forest maturing. As with the case of the great nightjar, many R-successional species have declined across Japan. So, plantation harvesting is expected to contribute to the conservation of R-successional species. As an important conservation target of R-successional species, we started the nightjar survey. As an effective survey method, we focused on a playback survey. After we played back the territorial call, nightjars misunderstood that competitors coming and they called back. Then we recorded the number and places of individual responding. We could detect efficiently nightjars for only 10 minutes, and detection probability remained constant regardless of the season and the time of day. I would like to show some short videos when the great nightjars responded. An individual was flying slowly over me, looking for a phantom rival. Again. Okay, next one. 2 adjacent individuals came close to me after the playback, very fast. I'm very sorry for their fighting. In the first study, we selected 125 survey sites across Hokkaido, northern Japan. Then we collected the abundance data of the great nightjar and analyzed it with environment data. Please look at these figures showing the effects of forest cover within 4 km and the average temperature during the breeding season on nightjar abundance. Dots indicate observation, and these lines indicate the estimates derived from the model. Their abundance was higher in area with moderate forest cover, peaked at 75%, and in areas with higher temperature. Finally, we made the abundance prediction map using the estimated relationships. In areas with higher nitrogen density, like here or like here, plantation harvesting was anticipated to promote nitrogen abundance or occupancy. Since 2015, we have continued the survey to examine the effects of plantation harvesting on nitrogen occupancy. The study area was shown in black in the left figure here. The nitrogen abundance in this area was predicted to be high here. The temperature range of study sites was 15.5 degrees Celsius to 19 degrees Celsius, corresponding to the range that nitrogen abundance increased with temperature. The study sites were located at the foot to mid-slope of a mountain, and the elevation was used as a surrogate for temperature. The landscape was dominated by plantations of totopher, an evergreen conifer tree species. Study sites were established in the retention experiment for plantation forestry in Sorachi, Hokkaido. In this site, we explored whether retaining some canopy broadleaf trees in harvested totopher plantations might enhance the multifunctionality of the plantations, including biodiversity conservation. Sites were selected in 5 harvesting treatments: clear cutting, small medium, and large amount of single tree retention and group retention. We also have two types of control sites, unharvested mature plantation and natural broadleaf forest. Each treatment had 3 replicates, so there are 21 sites in total. For 5 sites, we surveyed before and after harvesting. To examine the effects of plantation harvesting on nitrogen occupancy, we used generalized linear mixed model, a statistical model. To examine the effects of harvesting at the stand scale, we analyzed using the harvesting treatment of survey sites. That is, the site was harvested or not. However, we assumed that the grain nightjars would also use areas surrounding the study sites because of their large territory size and home range. Furthermore, wind slow occurred in forests adjacent to some site, immediately followed by harvesting and planting. Therefore, our analysis of young forest cover included the surrounding of each site. Let me turn now to results. Please look at this figure, derived from the model using harvesting treatment of study site. Nitrogen occupancy tended to be high in harvested sites compared to unharvested sites. Elevation negatively affected occupancy. The next figure is afforded by the model using young forest cover. Nitrogen occupancy was higher in area with young forest cover within 500 meters and lower elevation. Reflecting these patterns, the increment in occupancy probability at plantation sites with increasing young forest cover was predicted to differ greatly according to elevation. In sites with high elevation, occupancy probability was almost unchanged. By contrast, as young forest cover increased, the occupancy probability greatly increased in area with low elevation. Our results indicate that plantation harvesting can contribute to grain nitrogen conservation. Open environments near forests are suitable not only for nesting, but also for foraging. Many nitrogen studies in Europe supported this idea. By contrast to our study, no elevation effect on nitrogen occupancy was detected in a previous study conducted in warmer region of Japan. Thus, our results were likely a reflection of temperature effects. There are two possible explanations for this finding. First, the availability of flying insects tend to be lower under cooler conditions. Second, nocturnal flying vertebrates may be physiologically sensitive to temperature. Despite the moderate spatial extent of our study region, there are large spatial differences in the nitrogen response to plantation harvesting or young forest cover. Our results provide valuable insights for designing conservation strategies for early successional species, including the grain nitrogen. Considering climate and elevation in target areas is important when implementing plantation harvesting for effective habitat creation. This is essential for promoting effective biodiversity conservation efforts in balance with timber production. At last, I would like to introduce our ongoing study. We are extending our approach to the national scale and merged species, including our species. The aim of this large-scale survey is to review the effects of plantations and their harvest on nocturnal birds across Japan. Stay tuned for our next research. Thank you for listening.
Thank you, Kazuhiro, for that excellent presentation. That was fascinating, and congratulations on completing such a long-term effort. Long-term monitoring is a real undertaking, so it's quite an accomplishment. If anyone has any questions for Kazuhiro, you can put them in the chat, and we will address them. We've got about 1 or 2 minutes for questions, if anyone has any. Okay, so we've got a question here. So is the timber company that runs the plantations, or is there a timber company that runs the plantations, and what is their support or lack thereof? So does the timber company support the research that's going on?
Yeah, not really. And in this project, scientists and practitioners of forest management tasked to review the effects of retention forestry and so
Oh, no problem.
Yeah, I'm sorry.
No problem at all. And feel free to respond in the chat too, if you prefer.
Yeah. After this section, yeah.
Yes, exactly. No problem at all. You had a comment from Mark, very interesting. It looks like I'll look at the gray nightjar, especially after you telling me about the status in Japanese folklore. Would you want to just briefly speak to the folklore element that was shared?
Yeah, in Japan, there is a very famous folk tale in English, and the Star of Nighthawk, yeah, and a very sad story. And lastly, the nightjar become the star with very sad emotion, the crying.
Fascinating. Excellent. Okay, well, if there are any other questions for Kazuhiro, please put those in the chat. Thanks again for your talk and for all that you've done over the last almost 10 years. It's quite an accomplishment.
Thank you for your listening and questioning and comments. Thank you.
All right, so we will move to our next presentation. Our next presentation is titled Habitat Associations and Abundance of Chuck Will's Widow and is presented by Natalie Ramos. Natalie is a master's student at the University of Georgia studying the breeding and movement ecology of Chuck Will's Widow in coastal Georgia.
Hello, everyone. Thank you so much for having me. Today, I wanted to talk about habitat associations and abundance of one of the most charismatic and understudied nightjars, Chuck Will's Widow. So I wanted to take a moment to acknowledge the owners and staff on Little St. Simon's Island, where most of our work took place this summer, as well as Georgia Audubon and Georgia Department of Natural Resources, because without their help and support, this project would not be possible. So I've broken up my talk into 3 parts. The first will be a brief natural history of chucks and their conservation status, as well as knowledge gaps we aimed to fill in our study. Then I'll talk about the work we did over the summer on Chuck Will's Widow in coastal Georgia, specifically the point count study. And lastly, I want to outline possible management implications for the species and future research directions. So Chuckwell's widows are the largest North American nightjar, and they're historically found near swamp edges, open pine and oak wood, and pine barriers. They spend most of their days resting on horizontal tree limbs or on the ground where camouflage makes detecting difficult. And long-term monitoring data indicates that Chuckwell's widow populations have declined by at least 69% since 1966. Though the causes of these declines are not well understood, their nocturnal and secretive nature have made it incredibly difficult to study the species, which really limits answers to important habitat questions we might have for management implications. So Chuckwell's widow are currently listed on the International Union Conservation in Nature Red List as near threatened, but they're also included on the list of common birds in steep decline, which is a list of 24 birds that have lost more than 50% of their population over the past 40 years. And while this may not warrant watch list status, it's important to note that they're in critical decline. So not only do Chuckwell's widow occur in low numbers and over limited distribution, but they're also subject to stochastic threats that are damaging to their current population status. And these threats include breeding and wintering habitat loss and degradation, urban development, and pesticide use. Habitat loss and degradation potentially disrupts foraging and nesting behavior. And as aerial insectivores, their dependencies on flying insects have made nightjars so incredibly sensitive to the use of pesticides. And many species, including chucks, are also experiencing dramatic declines due to decrease in food availability that's directly linked to climate change. Population declines of aerial insectivores, they're clear indicators of poor environmental health, so it's important that they're studied further. So past research indicates that chuck abundance may be increased in heterogeneous landscapes and also positively linked to burning and thinning of forests. But the effects of landscapes on movement patterns, nest site selection, and even breeding success remains poorly understood. The few studies done on the species have provided us with very limited knowledge about nesting ecology, habitat use, and general population information. So our study aimed to fill knowledge gaps on specific landscape and habitats selected by chucks. So our study site was located on a small privately owned island off of the east coast of Georgia in the US called Little St. Simons Island. The island is an eco-lodge that is virtually an undeveloped landscape of over 10,000 acres of managed wildlife habitat. So the ecological staff maintain their grassland habitats through regular prescribed fire regimes, and they also manage predators as well. So this made it an ideal location to study chucks on the island because it includes a variety of intact habitats that support their numbers in higher densities than surrounding areas. And as a ground nesting species, the lack of invasive predators, particularly feral hogs, likely also provides additional benefits to breeding Chuckwell's widow. So the map on the left highlights our study site along the Georgia coast in the southeastern United States, and the zoomed in map on the right is of our study site. So Little St. Simons Island classifies maritime grasslands and maritime forests. So we've highlighted the two. Yellow is the grasslands and green is the forest. And we focused on these in our study as potential chuck used habitats. So between May and July of 2022, during suspected peak of Chuckwell's widow breeding season, we conducted 3 rounds of point count surveys for chucks. So 28 point count locations were distributed across the island, but they were all within 20 meters of existing roads. And these roads included dirt roads, trails, open paths, and grassy areas, as the island has no paved roads. And this was done to maximize efficiency during surveys and just make traversing the island fairly reasonable and efficient as well. So past literature suggests that chuck activity increases when there is sufficient light from the moon. And we also found during our surveys that chucks were most vocal when wind and rain were minimal. as well as within the first 1 to 1.5 hours after sunset. So we restricted our surveys to these conditions. And they were conducted with an initial 3-minute passive point count survey, which was followed by a series of 1-minute segments of broadcasted chuck calls 3 times. So 3 1-minute segments after the 3-minute passive survey. And during the survey, we recorded detections within a 250-meter radius. And we accounted for temperature, wind, and precipitation conditions. And the data from these point counts were used then to quantify chuck abundance across the habitats on the island. So to analyze our point count data, we use distance sampling models that are in a package in unmarked R, which fit hierarchical models of a species' abundance and occurrence during a survey, such as a point count survey. So our detection covariates that we focused in this model were survey date, start time. We accounted also for wind, temperature, moon phase, and cloud cover, but did not for precipitation, as we did not go out during the times that it was raining because we did not hear chucks during those times. So abundance covariates fitted in the model were land cover type and time since habitat had been burned with prescribed fire, as well as proportion of grassland. So after plotting the data, we can see a positive relationship between the proportion of grassland available at a survey site and chuck wool's widow abundance. Little St. Simons Island actively manages their maritime grassland habitats with prescribed fire. So we wanted to further investigate the relationship between chuck abundance and burned versus unburned sites, because even if this is a slight positive relationship, it still shows some positive relationship to grassland habitats. So this next figure illustrates the relationship between chuck and abundance and habitat type, where we can see that on Little St. Simons Island, chuck wool's widow are higher in abundance in unburned grasslands relative to burned grasslands and unburned forested habitats. And this really surprised us because we expected that they would be more abundant in forested habitats relative to grasslands based on past literature we'd read. And Little St. Simons Island provided us with habitat classifications of what they considered maritime grassland and maritime forested habitats, which is how we began the prediction that they would be more abundant in forested habitats. But thinking of these habitats as just forest and grassland is far too simplified when you're analyzing the landscape. So what we actually have in these habitats is a forest with a very dense understory that is dominated with saw palmettos. And then on the flip side, you have burned maritime grasslands, which are these muley grasses, which are more representative of what you would find in a true coastal grassland. And these burned grassland sites, which are more similar to early successional forests. So if you look at the unburned maritime grassland, it has that grassy understory, but since it's been a while since it's been burned, these wax myrtles have had time to grow upwards to 15 feet, providing cover and hiding opportunities for chucks. So this landscape is actually where I detected my first chuck. It's very slightly visible in the photo, but this heterogeneous landscape has these wax myrtles and more woody vegetation, and amongst these are open patches of ground, which could very well be why chucks are choosing this landscape as opposed to burned grasslands and unburned maritime forests, because what we're seeing in these two other landscapes seem to be two extreme ends of the spectrum, where recently burned habitats have little understory and unburned habitats, forested habitats, might have too much. And so perhaps what chucks are looking for is a mosaic of forested habitats with late stage grasslands, as there are enough open sites for roosting and foraging, but also enough cover for hiding and nesting. So the main takeaway is that if you look at across all available habitats on the island, when they have no other choice, chucks are going to choose unburned grasslands over forested habitats. And this could suggest that forest burning might be beneficial to chucks. Because the island actively burns grasslands to help maintain endangered muley grasses, while it might not be helpful to chucks, prescribed burns in forested habitats could. And the caveat in the study, and one that we have to consider, is that our research was done on a barrier island, so our findings might not apply to inland areas with different habitats or different predators, but it also might. So there might be a significant relationship between chucks and burn sites in the forest, but collecting more data to understand it in our second field season will hopefully show us a significant relationship between chuck abundance and habitat. Little St. Simons is actually burning their forested habitats for the first time in a very long time this winter. So we'll get a chance to look at before and after effects of chuck abundance in these landscapes. But all in all, chucks never fail to surprise me. And we expect that our next field season will help answer some of these questions, but possibly, surely will leave us with more. But with that, thank you so much again, and I'll take any questions.
Thank you very much for your talk, Natalie. We already have some questions popping up in the chat. So let me pull up the first one here. So are there any other nightjar species that you're finding in your study area?
Yeah, so the other species out in that landscape are common nighthawks, and we're actually hoping next season to investigate some integration or segregation between the two, because we're finding common nighthawks in those recently burned grassland habitats that are dominated by muley grasses. So yeah.
Fascinating. Yeah, that makes sense. So we've got another question here from Rebecca, actually 2 questions. So the first being, how far apart were your survey points? Rebecca's were 750 meters and felt like those points were too close. And then a second question is, do you think using broadcast calls significantly affected the numbers that you detected?
Yes, so for the first question, they were 500 meters apart. So we kept those 250 bands quite close to each other. But chuck calls carry, so I wonder if the 750 meters might benefit us in the future. But broadcasting calls definitely affected the number of chucks that we detected. Even my first point count, the first 4 minutes I was out there, I hadn't heard any calls. And then 5th minute, or actually 4th minute, when I broadcasted the songs and calls, it was almost like a symphony of chucks emerged. It was just 6 chucks just calling and singing. So I definitely think that's something that we also want to investigate, playback calls in terms of detection.
Yeah, excellent. That sounds awesome. A symphony of chucks would be a great thing to hear. Yeah, you're getting many positive comments here in the chat, including that it looks like a great location to work. I was thinking the same thing.
Yeah, it's very different from, I feel like, even managed inland areas. So it's a great opportunity to go out there.
Yeah, it really is quite a fascinating mix, with one of the comments being mosaics for the win, which I think is excellent. All right. Okay, so if there are no other questions, we will move on to our final presentation in this session. So the final presentation is titled, Are Protected Areas Enough to Conserve Breeding Nightjars? And this is presented by Elora Graham. Elora is a PhD candidate with Gow Lab at the University of Guelph, where she's studying common nighthawks and eastern whippoorwills. Her research is focused on breeding ecology and migration for both species, with a goal of filling knowledge gaps and informing conservation management strategies. All right, we will let Elora queue up her presentation here. Elora is going to present live. And she just let me know she's grabbing some headphones here. So whenever you're ready, Elora.
I actually could not find my headphones, but can you hear me okay?
Can hear you just fine, yeah.
And can you see my presentation?
Yes, right now I'm seeing just the, there you go, let me see when you, yep, perfect.
Okay, Okay, cool. Bear with me, everybody. I'm very tired from trying to get code to run. So we'll see how coherent I am today. So yeah, so the title of my talk are protected areas enough to conserve breeding nightjars. I'd like to give a special shout out to Carl T. Heide because there is a lot of nest vegetation involved in this, and I would not have been able to do that without his expertise. And he wasn't paid, so thank you so much, Carl. Okay, so I'm sure you're going to see these figures throughout the conference, the Sauer et al. Figures, but I have two study species in Ontario, and both of these species are declining in Ontario. They're also declining throughout their range, but the listing in Canada is actually threatened for whippoorwills, and special concern are threatened for nighthawks as well. But they are not yet listed federally in the United States. So our first species that we'll discuss is the eastern whippoorwill, or Antrostomus vociferus. And in this figure, the figure is showing data from the breeding bird survey from 1966 to 2011. Bear in mind, the breeding bird survey is actually horrible at detecting whippoorwills because they call it nights. And the breeding bird survey takes place shortly. It starts shortly before sunrise, but you can only get whippoorwills really at the first two stops of those surveys. They also only survey roads, so there's some limitation there. But the data, the red area illustrates areas where there has been very, very steep decline for whippoorwills between 1966 and 2011. And in Canada, from 2002 to 2012, they declined by about 2.7 to 5.5% per year across their range. So it's a pretty steep decline. And because they're so tricky to detect as well, continued monitoring, especially through the Canadian Nightjar Survey, is really important to assess how they're actually doing in terms of their numbers. My other study species is the common nighthawk, which has a much broader range. It breeds throughout the United States all the way up into Nunavut in Canada. So the breeding bird survey is also limited in that it only takes place in the southern parts of Canada, which I guess makes sense because the roads there are more accessible. But you can also see with the common nighthawk, which is far more detectable by the breeding bird survey. Still not great, but more detectable because they're more crepuscular. They can come out at day. They are also experiencing very steep declines throughout the range. So this is the same time period on the map, 1966 through 2011. But in Canada, between 1968 and 2005, they declined about 80% across their range. So very steep. So both of these species are long distance migrants. And the thing about long distance migrants is we often ask the questions, what are causing species decline? But when you have a long distance migrant that travels so far, at what points in the annual cycle do these factors occur? So this is the range map for the eastern whippoorwill over here. And we'll take a look. This is the common nighthawk range map, but they also extend all the way down into South America. So it's quite possible they go to northern Argentina. Ellie Knight's work with Janet Ng showed that the nighthawks they tagged in that study spent their winter in Brazil. So a big question with this, as I said, is where are these declines occurring? What's causing them? And there's been a lot of push towards the idea that it could be habitat loss along the migration route and also on the non-breeding grounds, which is honestly a very colonial assumption, because I think the assumption is that, oh, well, North America is doing so great at conserving the species, it must be something that's happening in South America. But that might not necessarily be true. So we really can't rule out the breeding grounds, especially in Canada, especially on conservation areas in Canada. So my study area is a place called Torrance Barrens. It's in Ontario. Those of you from the US and Canada might recognize the Michigan glove. So Torrance Barrens is just north of Toronto by a couple of hours, Toronto being one of the biggest cities in Canada. Also probably the most globally well-known city. Sorry, Vancouver. So it's approaching, it's getting close to boreal forest, but it's still a combination of deciduous and coniferous forest, and it's a rock barren. So there's a patchy landscape. It's a rock barrens interspersed with wetlands dominated by oak, white pine, maple, and lots of shrubby common juniper as well. So for the nest monitoring of these species, both of them have really remarkable nest camouflage. They also make ground nests, and they have, well, they don't make them. They just literally put their eggs on the ground. And they also have semi-precocial chicks, which means that the chicks can wander around a bit after hatching. They're hatched with their eyes closed. They open them shortly thereafter. They can hop short distances, and they can hop a little bit more with each day of growth. So if you hadn't seen her yet, this is the common nighthawk in the photo, one of the birds at my nest site, who I actually monitored her for 3 years over 5 nests. She's a very good bird. And then we also have the eastern whippoorwill, and you can see that what they're doing with their camouflage is different. I would like to point out, I had my headlamp shining on this bird, so I think that kind of like revealed her location a bit more than you might see it, or if she was just sitting there during the day. But so at the site, what we noticed is that these birds are having notably poor nest success. And we want to know why these nests are failing. Now, I know you probably really want a survival estimate, and I really tried my best to get RMark to work, but it's a tricky program, so you're going to have to wait for those results. What I can tell you is that in the last 3 years of my study, so from 2019 to 2021, I monitored 28 nighthawk nests. And keep in mind, every nighthawk nest has 2 eggs, so you'd expect 2 chicks, right? Well, only 2 fledglings out of those 3 years actually made it to migration. So their success rate is just remarkably poor at this site, which is shocking because obviously that's not sustainable, and it suggests that that site is a population sink. So what is happening and why are they failing? I had multiple methods to monitor the nests, and I know it sounds really intense, but I really did my best to make sure we weren't interfering as much as possible. So first we would set up a nest camera, but I would make sure it was at least 5 meters away, and it was a no glow nest camera. So that meant that animals couldn't see the infrared light. So they weren't attracted to it. And it also ensured by the distance of the camera that if anything wandered by and sniffed it, it wasn't going to find the nest just because it was smelling the camera. We also checked at most every 3 days to minimize the disturbance of the nest. And in the last couple of years, because we were finding more nests, there were times when there would be 6 days in between checks. So we were really, really limiting the amount of time that we spent at that nest, and the amount of time that we went towards it to reduce leaving any kind of trail towards it. I would also tag the female as soon as possible. With whippoorwills, this could happen during the egg stage. They're more tolerant. Nighthawks, not so much. So with the nighthawks, I would have to wait until the nestlings were maybe 6 days old just to make sure she wouldn't abandon them. And tagging the female is very important because they're so camouflaged, and because they wander around so much as they get older, it allowed me to find where she was quickly without, trampling all over the habitat. The last thing is that we tagged the nestlings around day 10 to 14. And the biggest thing was making sure that they were fairly mobile and that their feathers were big enough to cover the tag for the camouflage. So I wanted to make sure that when I put a tag on these chicks, they were still able to hop around or to fly. Some of them I wouldn't tag until they were in this sort of early fledgling stage where they could do very short flights. So I just really wanted to make sure that it wasn't that the tag was getting caught on something and that was causing the nest loss. So through this monitoring, we found some really interesting things about the nightjars at my site. And I think that it probably is true for the species at other sites as well, although it still needs to be confirmed. So with the eggs, and this is in the literature as well before my study, common nighthawks on the left, eastern whippoorwills on the right, have an incubation period of about 21 days, it can be 20 to 22. And then reaching independence, however, it takes quite a bit longer than the literature suggested, the prior literature. So here we have some eastern whippoorwill chicks getting their camouflage in. What I found at my site with both species is that the female brood the young for 4 weeks after hatching. So even though prior literature was sometimes calling fledging at about 2 weeks, what I was finding is that no, they're really not independent yet. And in fact, the mother should still be brooding them. So in this picture, there is a common nighthawk brooding one of the chicks that made it, just to give you a happy story. And this chick is almost 4 weeks old at this point, so about the same size as the mom, but still being brooded. Very, very adorable. It's also important to recognize that the nest area changes quite a bit. So in the egg stage in the first week, the nestlings really don't move that far from the original location. However, unlike other birds, like altricial birds like robins, they do not have fecal sacs, so they're just kind of pooping in place. And that's one of the reasons that the female is going to be moving them around so that predators cannot smell the droppings, and also because the droppings, I'm sure, would attract bacteria and things that wouldn't be good for the chicks. So after that first week, they're getting more mobile and they're starting to move. And at that point, the nest area kind of changes. They can go much farther than 1 meter from the nest, even up to 20 meters in the later part. Sometimes more than 20 meters I saw at my site. And I think other studies have seen movements of up to 50 meters. So the chicks become more mobile, but also the camouflage shifts because they grow in a different kind of plumage that allows them to camouflage in different areas. And as they're flying around, they're also making more choices about where they're going to be sitting instead of the mom shuffling them around. So my big question with this study was, what is the nest area composed of? There really haven't been thorough studies done on nighthawks or whippoorwills with vegetation, so it was important even to describe the vegetation at the site. So I've pictured one of the plots here, and the method that I used was developed by Tim Forrester, who is working with the common nighthawks at Ellie Knight's project, her PhD project in Alberta. So I was adapting our survey methods from that protocol that he rigorously developed. So we used both a 1 meter quadrat, which in this case represents the egg stage and nestling week 1. And we also used an 11.3 radius plot that represents nestling weeks 2 through 4 in the case of my study. So the ropes that you see there represent that bigger plot. And the reason we use 11.3 meters is because the total square area winds up being about 400 meters. So today I'm just going to share the results of the 1 meter plots. So what we did is we identified all the species of shrubs and trees within the plots, as long as they were more than 5%. So if there was something that was, less than 5%, just like one tiny little shrub in the big plot, we wouldn't worry about it. We also quantified the ground cover, such as leaf litter, pine needles, bedrock. We also, we did lichen and moss, which we kept separate. We kept dirt separate from the bedrock. And also all of these things, it didn't necessarily add up to 100. So you could have, for example, 100% leaf litter, but also 50% bracken ferns, because the ferns could be over the leaf litter. So the way that we analyze the results is we use something called non-metric multi-dimensional scaling. And this is something that was kind of tricky for me to understand at first, but I came up with an analogy for it that I hope helps you out. So you can specify however many dimensions that you want. And we used 3 different dimensions. So kind of imagine plotting these nest points in the cube. And what a non-multi-dimensional scaling model does is it's an ordination that's trying to group vegetation together by the similarities and the dissimilarities. So it's not using 1 to 0. So a way that you can visualize this with liquids is imagine that you have a bunch of liquids that you need to sort along axes, and you plug them into a computer, and the computer is going to be the one that determines what's important on these axes. So maybe one of the axes is water on one side and oil on the other side. So that would be like the viscosity. Maybe another axis is water on one side and milk on the other side. So that's like how opaque it is, how well can you see through it. And maybe another axis is temperature. So you'd have ice water on the left side of the axis and boiling water on the right side of the axis. And then basically what the computer's doing is within these three axes, which would be aligned kind of along a cube sort of structure, a three-dimensional space, it would ask, okay, so you have a glass of lemonade, where are you going to put it along these axes in this space? Or maybe you have a cup of coffee, where are you going to put that along the axes, and how does that relate to the lemonade? So with the nest vegetation, it gets a little bit more complex because it's not just one liquid, it's a group. So it's, instead of just looking at plants individually, they're looking at how all of these factors are grouped together and where are we going to put those nest points on the axes. So I'm going to show you the results of it, and I'm actually very excited about them. In this figure, so every one of these points represents a data point. We did paired nest plots. So we did a true plot, and then we also did a random plot that was in an area within 50 meters of the original egg location. So the squares on this plot represent common nighthawks. The blue squares are the true nests, and the very light blue squares are random. Circles represent eastern whippoorwill nests. So the dark yellow circles are the true nests, and the light yellow are the random plots. I don't know why that was animated, sorry. The 1 meter plot results. So what we actually find here is that there is niche partitioning. So what I've done is I've drawn some vector borders around the clustered points. And the solid yellow line is our whippoorwills, and the solid blue line is our nighthawk. So what you can really see is it's kind of this Venn diagram where there's a bit of overlap between the two, but really they're using different habitats. And that makes a lot of sense when you think about it, because they're ground nesters. They're both very territorial, especially nighthawks are quite aggressive, as anyone who's worked with them knows. And so they're both sort of evolved to take advantage of different sorts of spaces, and they're using different cues to select these spaces. So what did the computer decide the axes were? So I apologize for how clustered the text is. I have to figure out how to make it more spread apart. The two things that are overlapping here are bracken and teaberry, which is also called wintergreen. And down here, GSR is graminoid, so it stands for grass, sedge, and rush. So really what the pictures that I've added here, what the model, the NMDS, decided was the most important is on the left end of the x-axis, we have leaf litter. And on the right end of the axis, we have bedrock and reindeer lichen, especially. That's the type of lichen that's most dominant at Torrance Barrens. And then NMDS2 is on the y-axis. And it's slightly less important. And the reason that I know that is because it's sort of pulling nighthawks up a little bit towards pine needles, but it doesn't have as much of a pull on, bringing them or bringing those two vectors apart. So you can see there's a bit of a tilt, but really the differences are on that x-axis. So definitely the whippoorwills really like leaf litter, and the nighthawks really seem to like lichen and bedrock. However, one of the things, if you recall at the beginning of my talk, I said that the nighthawks had failed so much that there was only 2 chicks fledged out of 28 nests. The whippoorwills were doing better than that. I don't have an exact figure for you, but like, I feel like I have in the 3 years at least 10 chicks that were tagged and made it to migration. And I think it's a bit more than that actually. But you might wonder, okay, so what's going on at this site? It's a conservation area. Why are the nighthawks failing so much? And so they're selecting the bedrock and the lichen. And the thing about those is that they're in more open areas. The site is a conservation area, but it's not subjected to any management like burns. And it's very, very busy because it's a stargazing site, and it's the closest place with a dark sky within a couple hours drive from Toronto. So it gets a lot of people. There's a lot of camping. There's a lot of human traffic that goes there, both in cars and people walking around. And there's also a lot of garbage that gets left behind. The other thing about it is that these barrens, the rock kind of acts as a transportation corridor for predators. So the nests are primarily getting taken out by predators. And so the question is, why is that happening? Clearly what the nighthawks are selecting is maladaptive at this site in comparison to what the whippoorwills are selecting. So what exactly is happening in this conservation area that is causing the nest success to be poor? And that's what I'm going to be investigating as I take the next steps in this chapter. So what comes next is that I'll be analyzing the 11.3 meter radius plot with NMDS, and I'll also be looking at nest survival models. So do the MMDS results, particularly that first metric, which is the first score, the leaf litter versus rock barrens and lichen, predict nest survival, including the stage of failure. So does the rate of failure differ between the egg stage and the first week when they're using a 1 meter plot versus when they're using the bigger plot at 2 to 4 weeks of age? And it will also be trying to see if predator occupancy is related to these variables as well. So with that, I will happily take any questions, and also for the acknowledgements, very important. I had so many wonderful funders, and thank you to all of my field technicians. I really couldn't have done it without them. Also major nightjar support. So props to Ellie Knight, Felina English, and Alex Mills for helping me figure out how to find these nests in the first place. And also just Logan Parker for nightjar enthusiasm and really bringing this whole conference together as our fearless leader. Yeah, so does anybody have any questions?
Thank you, Laura, for that. Yeah, just looking at the agenda, we're slightly over time. So I just want to confirm, Yossi, are you here? Okay, so I think, yeah, we can take a few questions if anyone has some questions at this time while we get in touch with Yossi here. So you had a question in the chat for nighthawks. What parameters did you use to consider fledging?
That's a really good question, and I still don't have a perfect answer. In this case, when I say fledge and made it to migration, I mean that they made it past that 4-week period. So I recognize that in some cases we say that they're like a bird is fledged when they leave the nest, quote, and they're doing these short flights. And it's tricky to call that with the nightjars because, yeah, they'll do these short flights, but they're still very dependent on the parents. So they're not really fully flighted yet. They're still learning to hunt. So in terms of this chapter of my PhD, I'm going to be considering true fledging at 4 weeks. That's when they're not getting any support from the parents anymore. And I know there can be a lot of debate over that. I feel like it kind of simplifies thinking about the success of the nest, if that makes sense.
Excellent. So can you speak to some of your nest site, I should say, finding techniques? What sort of features did you hone in on when searching for nest sites for let's say for eastern whippoorwill?
Vibes. Well-wishing. No, so Ellie Knight taught me to look for eye shine, and that was a really, really good way to find the nighthawks. And also through Ellie Knight's research, I knew that the nighthawks were booming within about 100 meters of the nest. So I would really look for those consistent booms. There is also other behavioral cues with nighthawks, like barking. I call it barking. They kind of go rat, 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 and that definitely means you're close. With whippoorwills, I was looking for eye shine along edges, but whippoorwill males also incubate. So I could track the males in the middle of the night, and the males are easier to catch. And then sometimes you would catch them on the nest or at dusk. And Alex Mills is the one who gave me this tip. If you follow them at dusk, sometimes they just go right to the female at the nest to switch out with her. So it's a nice trick to try to find them.
Excellent. Okay, well, I just got a note that Yossi is here and has his camera on. So we're going to end session 4 here. Thank you very much, Elora. If anyone has any questions, please continue to ask those in the chat. And we will segue to our final section of the day, which is our keynote speaker. I'm excited to introduce Professor Yossi Yovel, who is a professor and head of the lab of neuroecology in the School of Zoology at Tel-Aviv University. Professor Yovel's research combines biology with technology. His work on bat biosonar has driven development of bat-like autonomous robots that navigate using sound only, as well as several other biomimetic applications in precision agriculture. His work on bats drove the development of miniature GPS sensors that allow tracking the smallest animals ever tracked before. His work on bats' use of biosonar for navigation in the field, in parallel with using MRI to study the bat's brains in the lab, made him establish a new field, which he terms neuroecology, which brings together the ideas of neuroscience and ecology. With that, I welcome Professor Yovel to begin his presentation.
Okay, thank you very much. Hopefully, can you hear me well?
Yes, can hear you great.
Okay, I'll share my screen. Thanks a lot for this presentation. Thanks for the invitation. Hopefully you're not disappointed. I'm not going to talk about nightjars and not about birds at all.
Not at all.
But I think that some of the stuff that we do might be relevant to some of you, and hopefully we can, I don't know, discuss later on how it can be relevant. So I don't have too much time. I'll be very, very quick and brief because I want to show you a few different stories. First of all, I'll present our general line of thought, and this is what you see in front of you. I like to say that my lab focuses on studying decision-making in the wild. What do I mean by that? So take your favorite animal model, probably a nightjar. In my case, it's a bat. This bat is about to forage, about to fly out to forage. So it's, let's say we're thinking of sunset. And now there are different types of information that this bat has access to, right? It can be its own sensor information, social information, cognitive processes, predispositions, and of course, environmental conditions. Now, the task of the bat's brain is to integrate these different types of information in order to make decisions such as when should I forage? So should I forage at all today? Where should I go to? Should I go to where I was yesterday or somewhere else? How should I forage? Should I forage alone or with a group, within a group? And these are all recurring processes, right? So the bat has to decide this every night, every season, every month, and sometimes even within one night again and again. So as mentioned in the introduction, we develop our own miniature sensors that can be placed on very small animals, including many species of nightjars, I think. And the idea is that this sensor is actually an array of many, many sensors. So of course we have GPS, so we can track movement, as you can see. We can track acoustics, which is very important for us. I'll show in a second why. So on the right top here, we see a recording, an acoustic recording. We can record physiology. Here on the bottom right, you see the heart rate of a flying bat. And we can also track acceleration or magneto. We have a magnetometer as well, but in this case, you see this red line is the wing beat. It's the Z acceleration of the animal, and it's a proxy of its wing beat. As I said, sound is one of the most important sensors for us. This is how we started everything. Sound is really useful when studying bats because of their use of echolocation. So most bats will echolocate. They will emit sounds while orienting, while hunting. And what you see here are sound recordings. So this is a spectrogram. We have frequency over time. And each of these red signals is actually a bat echolocation call. Now you see I can also record conspecifics, okay? So I can look at the interactions. By the way, I can also look at social vocalizations, right? So this might be more relevant for nightjars. Importantly, I can look at foraging. So what you see down here is an attack. This is a sequence of a bat attacking prey. You can see how the calls become closer to each other in time. Sometimes the prey emits sound, such as in the case of a frog. So I know that the bat is attacking a frog because I can hear the frog on the recording. And in this case, I know the attack was successful because I can hear the chewing sounds right after the attack. So I think I forgot to share sound, so I will not play the WAV file, but basically if I played it, you would hear the echolocation. And then eventually you would hear chewing. You would hear echolocation, chewing, right? Because the bat has to sense while it is feeding. So as I said, I want to, if I have time, I want to mention 3 projects. I will only talk about each one briefly that we've been involved with to show you the power of this approach. Well, actually, I do have to share sound, so I'll stop sharing for a second because this video has sound. Sorry, and I'll share with sound. Yeah. So the first thing we were looking at is a social behavior. Okay, so many bats are very social. You'll see in this movie. Hopefully, I don't know if you can hear me while I'm talking, but we're looking now at a greater mouse-tailed bat. And what you're listening to, that was the kestrel, by the way. And what you're listening to are their social vocalizations, not echolocation, but social vocalizations. And when observing this behavior, we wonder whether the bats are actually foraging together. Okay, so I'm not sure if you heard me while the movie was running, so I'll just repeat it quickly. I said this type of behavior is very common, and and we were running for some bat species, and we were wondering when observing it whether the bats are really searching together or whether, you know, they just roost together and then they fly out together. So do they benefit from social foraging? Now, in order to show you the results briefly, I will take you to another species, a different species on the other side of the world. This was in Israel, and I'm going to take you to Mexico, to the Sea of Cortez. Okay, you can see it here on the map. And the task that the both species, so before we looked at greater mouse-tail bats, and these are Mexican fish-eating bats, and their task is very similar. And in both cases, these are social bats. We see them roosting in large groups. Okay, why do I say that the tasks are similar? Because these bats forage on fish. The previous bats forage on insects, but in both cases, food is ephemeral, meaning that it's very hard to find. They don't know where they're going to find food, and they have to search very large areas when looking for food. Every night they have to research again. So what we see here, okay, so the problem is similar, and we've actually shown that the solution is similar. I want to show you this bats because they're slightly more, let's say, unique. Not many bats forage over the ocean as these bats do. So you're looking here at GPS tracks of one individual flying off. This is called Isla Partida. Okay, it's an island in the center of the Sea of Cortez. You can see that she flies. It's a she. She flies quite far at sea. Every night is a different color. So you can see that on the one hand, she's always covering this area in search, but on the other hand, every night she has to begin her search from scratch. She doesn't know where food is going to be. And what we found, and I'm going to show it in a movie, but we quantify it, of course, in the paper, in several papers. What we find is that the bats are constantly moving with other bats around them. So they are searching as part of a group. So what you will see in the movie, you'll see the bats flying off the island and then eventually returning to the island. The full flight is something like 6 hours. So they fly non-stopping for 6 to 8 hours. And on top of the trajectory, you will see 2 types of colors. You'll see red circles whenever the bat is foraging, whenever it found fish or something. And you'll see white circles whenever the bat is flying with conspecifics. Okay, you see these white circles. This means that they're nearby conspecifics. And so here was a small patch of fish. Here's another patch of fish, and here's another one. But what's more important are these white circles. Okay, notice that the bats are constantly flying with other bats around them. And basically, this is what we found. So this movie kind of summarizes what we found. We also quantify it with a model. I'll show you in a second. But the bottom line is that the bats are using the group probably in order to improve their searching. Okay, by the way, look at their amazing navigation. Somehow they managed to find a way at night over this dark ocean back to the island in an almost direct line. So why does it work? Why does social foraging work for this species? The idea is that food, both species or insects in the previous species, is ephemeral but patchily distributed. So when you find food, there's a lot of food, okay? And whenever a bat finds food, we know, right? How do we know? I showed you this before. Maybe I'll go back quickly. You remember this? When a bat hears this, it knows that another bat around it has found food, okay? And the idea is that the eavesdropping range, and this is what you see here, is much larger than the individual detection range. So as a bat, I can find fish from a few meters, but I can hear that another bat found fish from up to maybe 100 meters, maybe a little bit more. Okay, so altogether, this makes the group foraging very, very efficient. There's a bag of chips here because we call this the bag of chips effect. Imagine that you're sitting in a dark theater and somebody opens a bag of chips. Immediately, everybody knows that there is food over there. As I said, we also quantify this using an agent-based model, so mathematically, but not analytically. What you'll see in a second is a simulation. All bats are in the center on an island, and now they're moving according to local rules. So everything they know is to follow the nearby bat. As you can see, they form groups according to this behavior. There is food here. The food is sparse. It's difficult to find. And once a group, in this case, a small group finds it, but once a group finds it, you will see, like right now, that everybody or most of the bats converge onto the food. So this individual now does not know anything about the food. It is just following the individuals in front of it until reaching the food. We also wanted to show that this strategy can be designed using artificially using drones. So I'll show you now a very simplistic scenario of the tracking algorithm that we've seen before. What you will see in this short movie, is one of the students in the lab moving around with a speaker. The loudspeaker is emitting ultrasonic signals, and there's a fully autonomous, tiny 20-gram drone tracking it. So following it, listening to the speaker, and adapting its direction to fly towards it. Okay, so what's very important about this is that the drone is fully autonomous, okay? Nobody is driving the drone. I still have a few more minutes, so in the next few minutes, I will tell you a little bit about navigation in bats and how do bats learn to navigate. So I'm moving to fruit bats. Fruit bats can fly very large distances. You can see a fruit bat here that flies 20 and more kilometers. And the question, okay, and it's flying, I should say, it's flying to a tree more than 20 kilometers away from its colony. And the big question is here, how does it learn that there is a tree here? Okay, how does this bat learn to fly this very straight line towards this tree? Okay, so each bat knows several trees or many trees. This is just one example. But the question that I'm going to talk about today is how do they learn this? And so the two students, the two very good PhD students, great PhD students, Liel Ten and Aya Goldstein, who ran the project. And we were wondering whether you can see here a pup being carried by its mother. And we were wondering whether this behavior plays a role in learning where to navigate. We study this in a slightly different environment, in an urban environment, because it's easier for us to track bats in this environment, not so far from the lab. And what Aya and Lee did is they placed our GPS tags both on the pups and on the mothers, okay? And I'll briefly describe what we found. So what you see here, so this is what we see during the first 10 weeks of the animals, of the pup's life. So until the third week, the pup is always carried on its mother. But starting at week 4, the mother will fly to a tree that is something like 1 kilometer away from the colony. It will drop off the pup. Okay, so this is this dashed line. You see the pup in orange being carried by the mother. I'll explain how we know that it's being carried. And it is dropped off on the tree. The mother continues. She flies somewhere else. She forages. She comes back later at night. She picks the pup back and brings it back to the colony. Now, around week 10, we see a shift in the pup's behavior or in the mother's behavior. The mother stops carrying the pup out. She will fly out alone and leave the pup in the cave. And what we see is the pup flies alone to the exact same tree where it was carried to by its mother previously. Okay, so look at the trajectory. It seems like it's following. Now it's flying alone, flying to the same tree where it was left before. And gradually it starts increasing its exploration and learning to navigate through the environment. And what we hypothesize is that the pup learns to navigate to the tree while being carried by its mother. Okay, you can see here a mapping of the trees. So we tracked several dozen pairs of mothers and pups, and you can see the drop of trees all around the colony and distances that range between several hundred meters and until a few kilometers. How do we know that the mother is carrying the pup? We have accelerometers on the mother and on the pup. You can see here the acceleration of the mother and the pup, and you can see how the two are perfectly synchronized. They're in opposite direction because the pup is carried on the mother. So, you know, one is upwards and one is downwards. But we know that in all cases, the mother carries the pup. The pup is never flying behind the mother. So what is the purpose of this type of behavior? We think, although it might not be the only reason for the mother to carry the pups, but we think that the mothers teach the pups how to navigate to a location where they later on know to find them. Okay, so I'll give you two examples that support this idea. So here's one example where the mother leaves the pup in the cave. She flies out, this is in green, but the pup fails to fly out. She comes back to the cave and the pup is still there. Okay, you can see the hours here. And then on the next night, what she does is she goes back one step backwards. She then carries the pup again to the same tree and flies and carries him back. So she's going one step backward in her behavior. And starting on the next day after that, the pup starts flying out on its own. Here's another example that I like very much. In this case, the mother flew out, as you can see, and the pup also flew out in orange. Okay, the pup flew to the same tree where it's a drop of tree. Okay, but when the mother comes back around 2 a.m. or 2:30 a.m., the pup is not in the cave. And then what the mother does, she flies out at 3:20, so an hour later more or less. She flies out. Where does she go to? She goes to the same tree where she used to drop off her pup. And indeed, she finds it there and brings it back to the cave at 4:20. So we think that these, we call these trees anchors for navigation. The mothers know that the pups will be around them, and therefore they can assist guiding and assisting the pups, preventing them perhaps from getting lost during their first flights outdoors independently. So I think that I kind of ran out of time, so I will not talk about the third story in which we show that bats also have some kind of long-term memory about the availability of fruit and nectar in the environment. This is a story that we've just submitted recently, so it's very, very new. And we suggest that bats have some kind of a episodic-like memory, if you want, about the availability of resources in their environment. This kind of summarizes it all. If this is the colony, then we suggest that the bats know where the food is. They know something about the temporal state of the food. This is the z-axis. And they also know something about the number of conspecific, the social value of the research. Finally, I have to thank a lot of students and, of course, funding agencies that took part in all of these experiments. And that's it. If you have questions, I'll be happy to answer.
Excellent. Thank you so much for that fascinating presentation. I think many of us can recognize there's quite a lot of potential for crossover to our research with nightjars, but yeah, absolutely incredible. I think we could take a minute or so for questions, if there are any questions. I do see one that just popped up here, so we might have time for just one question. So Rebecca says, the mother-pup flying relationship is fascinating. Do you know if this behavior occurs in other microbat species? In the Midwestern US, our bats are insectivores and much smaller, but have high site fidelity to maternity roost. Do you know if they might exhibit the same behavior?
Yeah, so the short answer is no. I will try to say a few words. So I'll say that bat species divide. Some bat species carry their pups out of the cave, and some do not. So in some cases they leave them in. In many, it's not necessary. Does not necessarily correlate with whether they're insectivores or frugivores. You have species in both sides that do both things. So I'm not sure. It depends on the species. But this drop-off behavior, I'm sure it occurs in more species. We just don't know which ones. Okay, so it's hard to believe. You know, the pups at some point they can reach a weight of 30 or even 40% of the mother's weight, and I'm sure that the mothers in additional species, I'm sure additional food species, but food bats, but maybe also insectivorous bats also exhibit this drop-off behavior. But as much as I know, this is the first time that anyone shows it and also tries to show what's the functionality of this behavior.
Great, and we have time for just one more question. Elora asks, or states, I think about this with oilbirds too. What is the point of being a nocturnal, sorry, it's scrolling on me. What is the point of being a nocturnal frugivore? Does it reduce competition with diurnal frugivores, or is there another reason?
Yeah, great question. I think with fruit bats, although there's some debate, they started off as echolocators. Again, there's some debate, so let's say this is one hypothesis, but the leading hypothesis, they started as echolocating bats and as insectivores, so the ancestors were insectivores, and then they became frugivores, and they were already active at night, and now you do see some species that went back to day. And actually, you might have some advantage during daytime with the fruit, right? Because, I don't know, you can use color vision. So it's an interesting question. We see here in Tel Aviv fruit bats that are generally nocturnal, active during daytime, something we even published recently a paper about this, something very, very new. In the case of oilbirds, I think that, well, yeah, it's not exactly the question. I was about to say that echolocation in oilbirds, which we also know that they echolocate, right, evolved for orienting in caves, right, because they are cave dwellers. But what is the advantage of flying out in the dark? I would say maybe avoiding predation would be one advantage. I'm not sure if so. If you're a nectarivore, some flowers, of course, open only during nighttime. But if you're frugivores, I can't think of any dietary advantage, and maybe the opposite. But very interesting question.
Yes, absolutely. Well, thank you very much, Professor Yovel, for that presentation and for answering those questions for us. We're really glad you were able to join us.
Thank you.
Okay, so with that, we are going to wrap up for the day. Let's see. We will be starting up tomorrow, day 2 at 1600 UTC, and we will be covering, again, 3 sessions on breeding ecology, breeding grounds and behavior, and migration ecology. And we hope that many or all of you will join us again tomorrow for that presentation. And yeah, I would ask, can one of our steering committee members post the block of links in the chat? So if you have any suggestions or concerns following today's presentations, please feel free to reach out to us, and we'll respond to you as quickly as we can. Again, I'd like to put in a plug here for the open positions on our steering committee. If participating in this presentation today has made you think about potentially joining our steering committee, we'd certainly love to connect with you. And yeah, we will have this recording made available in just a few weeks, and we will pick up tomorrow. Thank you, everyone, for joining us, and thank you to all of our presenters, those that were able to attend today or those who forwarded videos. Very grateful for your participation. Take care, everyone. Thank you very much for everything today. Thank you. Thank you to the steering committee members as well, who helped run moderate the chat. And shout out to Gabriel as well for running all of the videos today. That was extremely helpful and seemed to work quite seamlessly. So many, many thanks. See you tomorrow. Thanks.